In the silent depths of the universe, far beyond the last whisper of starlight, there exists a place where time itself begins to slow, a place where gravity softens, light bends like liquid silk, and the noise of life fades into a deep, endless calm. You're here with the gentle physicist, and tonight I'm taking you deeper than dreams, into the heart of the cosmos, into the quiet breath of a black hole. So let your thoughts settle, let your body relax, and allow the universe to guide you. Take a slow breath and drift with me into the most calming place in the universe. Imagine taking a slow breath and feeling the room around you soften, as if the edges of everything grew quieter for a moment. In that gentle pause, the world loosens its grip, and the night opens like a curtain revealing the calm of space. You drift upward without effort, leaving behind the hum of daily thoughts, rising into a darkness that feels warm rather than empty. Stars shimmer like distant embers resting on an infinite ocean, each one patient, each one breathing in its own quiet rhythm. And the universe, vast as it is, moves with a softness you can almost feel against your skin. There is no rush here. Galaxies drift the way slow tides glide across a shoreline. Light travels with the calm persistence of wind moving through tall grass. Even the great structures of space expand in a long, unhurried exhale. Everything unfolds with time measured not in seconds, but in centuries and eons, where every motion feels like a whisper stretched across eternity, and for a moment, everything feels still. As you move deeper into this cosmic quiet, the universe begins to reveal shapes carved not by chaos, but by patience. Gravity draws matter inward the way a gentle hand gathers fabric. It smooths, sculpts, and guides, forming curves so subtle they look like the signature of time itself. Black holes, often imagined as fierce devourers, appear instead as serene creations of this cosmic craft. They are places where gravity becomes so steady, so persistent, that space folds inward like a slow breath returning home. And in that inward fold, something remarkable begins. An invitation to explore how such calm shapes are born from the universe's deepest patience, and how softly they change the fabric around them. And slowly, the journey invites you to drift even deeper. If you listen closely to the night, you might notice how naturally your mind expects the universe to be loud, wild, bursting with sudden motion. But as you drift a little deeper into the cosmic dark, you realize something gentler is unfolding. Out here, everything moves with a patience beyond imagination. Stars do not hurry to be born. They gather themselves slowly from drifting clouds, taking millions of years to glow. And galaxies drift across the vastness like enormous underwater creatures, gliding through a silent ocean of space. There is no noise in the vacuum, no storms you can hear, no collisions that shake the air, just a quiet so complete it feels like the universe itself is resting. Even the temperature falls almost to absolute stillness, where atoms barely move. Light travels for billions of years without interruption, crossing distances so immense they soften the mind into calm reflection. And for a moment, everything feels still. If you could watch the cosmos unfold from this peaceful vantage point, you would see motion slowing into a kind of cosmic meditation. Clouds of dust swirl like soft ink suspended in water. Star clusters drift past one another without touching. Even when galaxies collide, Their stars slip through the spaces between, barely disturbed, like two flocks of birds merging in silent flight. The universe is not rushing anywhere. It is simply expanding, breathing, continuing its long, gentle unfolding. And within this great quiet, black holes settle into place as part of the rhythm. They don't disrupt the calm. They join it. They form slowly, patiently, at the ends of long stellar lives, becoming part of the universe's serene architecture. And in this cosmic quiet, something extraordinary begins when a star reaches the end of its soft, glowing life. There comes a moment in the long life of a star when its glow begins to soften, the way a candle flickers lower as the night deepens. For billions of years, it has shined with quiet devotion, turning simple elements into light that drifts gently across space. And now, as its fuel slowly fades, the star doesn't erupt into chaos. It relaxes. Its outer layers loosen like a warm blanket being folded away, drifting outward in soft waves that shimmer before dissolving into the dark. And for a moment, everything feels still. Inside the star, the pressure that once pushed back against gravity grows tired. Gravity, patient as ever, begins to gather the star inward, not violently, but steadily, the way hands might gather fabric toward the center. The star curls into itself with a quiet surrender, as if returning home. Its light dims, its surface cools, and its brilliant energy settles into a calmer, denser form. This is not destruction. It is transformation. As the collapse deepens, the core becomes unimaginably compact, a glowing ember pressing inward under its own weight. Gravity strengthens, folding the star tighter and tighter. Yet even here, the universe moves with grace. No sudden jolt, no explosive twist, just a slow, inevitable inward motion guided by the same gentle law that shapes galaxies and tides. The star is becoming something new, something shaped entirely by gravity's steady persistence. And in this quiet collapse, a question begins to form, soft as a whisper. What happens when gravity continues folding inward, deeper than the star itself, gathering everything into a single elegant curve of space? The answer waits in the darkness ahead, where the star's peaceful ending becomes the beginning of something even more mysterious. Gravity has always been the quiet sculptor of the universe, shaping everything from drifting dust to entire galaxies with a patience that feels endless. When a star grows old and its inner light begins to fade, gravity steps forward with its gentle steadiness. It gathers the star inward the way water curls into a slow, spiraling pool. There is no violence in this moment, only a deep, inevitable motion. Matter, folding back into the force that held it together for so long. And for a moment, everything feels still. As the collapse continues, layers of the star drift inward like soft ribbons being drawn toward a center. At first, the motion is calm, then gradually it becomes more focused, more precise. Gravity doesn't rush. It tightens its hold with the same patient rhythm it has used since the beginning of time. Each particle, each fragment of the star, follows the smooth curve of space-time as it bends gracefully towards the core. It is as if the universe is performing a slow, steady breath, exhaling light, inhaling mass. Eventually, the collapse becomes so complete that a new shape begins to appear, a perfectly curved well in space-time, deeper than anything else the star has ever known. This is where gravity becomes the star's final identity. Not a blaze of light, not a burst of fire, but a silent, inward curl, sculpted with exquisite precision. The star doesn't vanish. It transforms into a region where gravity's pull shapes space itself. And as matter folds inward enough, something subtle and extraordinary emerges, a boundary so calm and quiet that it feels like the surface of a still pond at night. A place where time begins to behave differently and where light lingers on the edge before fading into the curve ahead. Imagine drifting closer to the star's transformed core, where gravity gathers everything into a perfect, silent curve. As you approach, there is no barrier waiting, no sudden shift in force, no wall to cross. Instead, a quiet threshold appears, a place where light itself begins to tire. It climbs upward, tries to escape, but gravity's pull is gentle and persistent, and slowly the light relaxes back down, settling into the darkness like a sigh returning to the body. And for a moment, everything feels still. This boundary is called the event horizon, though the name sounds far more dramatic than the reality. It is simply the point where escape becomes impossible, not because of violence, but because the inward curve of space-time has become too deep. Nothing physical marks the location. If you drifted through it, you wouldn't feel a thing. Space would remain smooth around you, as if the universe were guiding you across an invisible line drawn only in mathematics. Above the horizon, light spirals softly, bending into arcs that shimmer like threads of gold on dark cloth. Some rays nearly escape, hovering briefly at the edge before sinking back into the quiet fold. Others curve around the black hole entirely, forming graceful rings that circle the darkness like halos. Everything here moves with slow inevitability, following the patient rules that shaped the universe from the beginning. And as you hover near this calm boundary, a new question begins to take shape. If light hesitates here, lingering before giving in to gravity's pull, what happens to time itself in this deepening curve? What does a moment feel like when it stretches so softly that even seconds seem to drift? The answer lies just a little deeper, where time begins to slow in the most gentle way. As you drift closer to the heart of this curved space, something almost imperceptible begins to change. It isn't the darkness, and it isn't the pull of gravity. It's time itself, stretching gently like warm taffy, drawn into a slow, delicate thread. Seconds lengthen, moments soften. Each heartbeat feels as though it floats a little longer before settling. And for a moment, everything feels still. From far away, an observer would watch you move toward the black hole, as if you were slowing down, gliding through honey-thick time. But from where you drift, nothing feels unusual. Space remains smooth, the path ahead unbroken. Time doesn't slam to a halt, it relaxes, loosening its grip on each passing instant. The universe becomes quieter, as though every motion has been wrapped in soft cloth. Gravity, deepening its embrace, tugs not only at matter, but at the fabric of time itself. Clocks near the event horizon tick more slowly than clocks far away, their rhythm drawn into a tranquil lull. Light rays stretch into longer wavelengths, their color fading into gentle reds as they lose energy on their climb outward. Everything becomes calmer here. Light, motion, even the flow of minutes. And the deeper you go, the more time settles, thick as velvet, peaceful as dusk. The world you left behind continues at its own speed, but here, near this quiet curve of gravity, time becomes a pool without ripples. It allows each moment to linger, to breathe, to rest. And deeper still, Gravity folds space in ways even stranger and softer, creating shapes and possibilities that stretch beyond familiar understanding. Something waits in that inward curve, silent, mysterious, and unexpectedly calm. As you drift past the softened edges of time, the space around you grows quieter still, as if the universe were holding its breath. There is no brightness here, no sound, no sense of falling, only a deep, velvety calm that gathers like dusk, settling over a silent field. Far from the stories of chaos and tearing forces, the center of a black hole feels more like an idea than a place, an idea where everything the star once was has curled inward into pure gravity, pure curve, pure stillness, and for a moment, everything feels still. The singularity is often described as a point of infinite density, a place where matter collapses beyond comprehension. But the truth is softer than the words suggest. It is simply where our equations stop knowing what to say. The language of physics becomes quiet here, like a voice fading into a whisper at the edge of a dream. Matter no longer behaves the way it once did. The familiar rules loosen, replaced by something new, something not yet understood, but strangely comforting in its mystery. Imagine the star's final essence compressed into a form so delicate that it slips out of ordinary description, not crushed, not shattered, transformed. Like a thought held so tightly, it becomes pure intention. In this inner stillness, gravity curves space so completely that direction loses meaning. Past and future fold into each other like pages pressed together in a closed book. The center is not a violent endpoint, but a quiet question mark, a place where understanding pauses rather than breaks. And as you linger near this mysterious calm, the darkness around you begins to brighten, not with light, but with the soft glow of what surrounds the black hole. Because just beyond this silent center, a surprising kind of cosmic beauty waits to unfold in spirals of luminous dust and gentle arcs of bending starlight. As you drift outward from the quiet center, the darkness begins to soften, as if painted with the faintest strokes of light. It isn't harsh or sudden, just a gentle brightening, like dawn appearing behind a distant hill. Here, matter circles the black hole not in chaos, but in elegant loops, forming what looks like a glowing river of stardust. Each particle glides along curved paths shaped by gravity, moving with a rhythm so smooth it feels almost musical, and for a moment, everything feels still. The accretion disk that surrounds a black hole is often imagined as violent, but from afar, its motion appears slow and beautifully ordered. Dust and gas swirl in wide spirals, glowing with warm colors, golden oranges, deep reds, faint blues, all blending like a soft pigment drifting through water. The heat is unimaginable, yet the movement seems relaxed, like a lantern flame swaying in a gentle breeze. The closer the matter drifts toward the horizon, the more its light stretches, bending into graceful arcs that wrap around the black hole's silhouette. You can almost feel the patience in this rotation. It continues for thousands of years, steady and unbroken. Each loop traces the invisible geometry of space-time, revealing curves that only gravity could draw. Some light escapes, traveling outward in shimmering threads. Some curves around the black hole entirely, creating halos so delicate they look like rings of spun glass suspended in the dark. And as you watch this glowing dance, a quiet realization settles in. Even near something so extreme, the universe remains poised, balanced, gentle in its own grand way. This glow, this slow spiral, is not a sign of destruction. It is a sign of order, of gravity's soft handwriting across the cosmos. And beyond this luminous river, another truth unfolds. Black holes, despite their darkness, help shape entire galaxies. Far beyond the glowing spirals of light, the black hole's influence stretches quietly into the wider galaxy. It doesn't announce itself or impose its presence with force. Instead, it anchors everything around it with a steady, unseen hand. Just as a calm heart keeps rhythm for the body, a supermassive black hole rests at the center of most galaxies, holding stars in gentle, balanced motion. They orbit not out of fear, but from the quiet stability gravity provides. And for a moment, everything feels still. Imagine billions of stars drifting in elegant paths, each one following a curve shaped partly by the dark, silent mass at the core. This central black hole acts less like a tyrant and more like a guide, helping the galaxy maintain its graceful spin. Without it, the sprawling disk of gas, dust, and starlight might wobble, twist, or drift apart over cosmic time. Instead, its presence gives the galaxy a center, a point around which everything can settle into harmony. And its role doesn't end there. Through gentle flows of energy and matter, these massive black holes help regulate the birth of stars. When too much gas gathers near the center, the black hole's soft but steady influence can warm the surrounding regions, slowing star formation just enough to keep the galaxy from burning too brightly or too fast. When things become too quiet, it allows new stars to bloom again in shimmering clusters. The galaxy breathes because the black hole helps set the rhythm. Seen this way, black holes are not destroyers. They are architects of cosmic balance. They shape, guide, and steady entire galaxies for billions of years, ensuring that stars have room to live out their glowing lives in peace. And they have been performing this gentle role since the earliest chapters of the universe, quietly sculpting the grand structures we see today. If you step back far enough, past the spiraling starlight, past the drifting clouds of dust, past even the glowing arcs around black holes, the universe begins to look like a vast, quiet tapestry woven from darkness and calm. Everything moves, but nothing rushes. Stars breathe in slow cycles. Galaxies drift like soft lanterns floating on an infinite sea. And in this enormous stillness, you begin to see how much the cosmos is shaped not by noise or chaos, but by silence. A silence so deep it feels almost alive. And for a moment, everything feels still. Black holes, scattered across this dark expanse, are part of that quiet foundation. They form slowly, evolving from aging stars that curl gently inward. Their boundaries, their event horizons, are soft thresholds where light pauses before giving in. Time itself stretches around them like a long, quiet exhale. Nothing about them needs to be rushed or forced. Their presence steadies the galaxies they live in, helping stars find order in their orbits and space find balance in its curves. Even the vast expansion of the universe unfolds in silence. No sound accompanies the drifting apart of galaxies. No roar echoes through the emptiness. Instead, distance stretches like a slow unfurling ribbon, gentle and patient. Every structure, from the smallest grain of cosmic dust to the largest cluster of galaxies, moves within this quiet harmony. And as you float in this immense calm, the truth becomes clear. The universe is held together not by chaos, but by quietness. Gravity guides with a soft hand. Time flows like a serene river, And black holes themselves, often misunderstood, are simply part of this silent architecture, anchors carved into space-time to help the cosmos hold its shape. Somewhere in this stillness waits another mystery, another soft truth. Because the most relaxing facts about black holes are often the ones no one talks about. If you imagine a black hole the way movies often show them, raging, hungry, pulling everything toward them, you might feel a small tightening in your chest. But the truth is so much softer than the stories. A black hole doesn't chase stars or suck in planets. It doesn't roam through the galaxy searching for something to consume. It simply rests where it is, shaping space with a quiet gravity, the same way any massive object would. And for a moment, everything feels still. If our sun, without changing its mass, were to become a black hole right now, Earth would continue circling it in the same calm orbit. No falling, no sudden pull, no catastrophe. The only difference would be the absence of sunlight, a loss of warmth, not a change in gravity. That alone reveals something gentle. Black holes are defined not by frantic force, but by the same steady gravitational hand that keeps planets in motion today. And across the universe, these objects are among the most stable things ever created. Stars flare, pulse, explode. Nebulae drift and dissolve. But black holes, they settle. Once formed, they remain for billions upon billions of years, quietly curving space around them like smooth stones resting at the bottom of a cosmic river. Their gravity doesn't lash out. It simply exists, patient and unwavering. When you picture a black hole now, imagine stillness rather than chaos. Imagine a place where gravity is calm and predictable, where nothing is drawn in unless it wanders impossibly close. Imagine an object shaped not by violence, but by the long, gentle persistence of time, and their calm nature becomes even clearer when you explore how softly they interact with the space and stars around them, revealing a universe far gentler than most people ever imagined. When you picture the gravity around a black hole, you might imagine a force that yanks and tears, something wild and unpredictable. But as you drift into the truth, you find something surprisingly gentle waiting there. Gravity near a black hole behaves exactly like gravity around anything else with the same mass. Stand far enough away, and it feels ordinary, no stronger than the pull of a star or a planet of equal weight. Space curves, but it curves smoothly, like a shallow, peaceful slope on a quiet hillside, and for a moment, everything feels still. Only when you drift very close does gravity become intense. And even then, its pull isn't a sudden snatch, but a steady deepening of the curve beneath you. Like walking toward the edge of a well, the slope grows steeper only at the final step. From a distance, the black hole sits silently, blending into the structure of its galaxy without disturbing the stars that dance around it. They follow their long, graceful orbits without fear of falling inward, the same way planets trust their paths around the sun. Most of the space around a black hole is completely calm and empty. Nothing stirs. No storms rage. No matter is ripped apart. Instead, you find vast regions of perfect stillness where gravity gently cradles the quiet vacuum. It is only the rare drifting cloud of gas or the adventurous star that wanders too close that begins to interact with that deeper curve. Think of gravity here as tides rather than traps, soft, predictable, shaped by elegant equations that guide the cosmos with patience. Once you see gravity's true form, the black hole becomes less a monster and more a quiet well carved into space-time. And this gentle gravitational shape leads to something even more beautiful, the way light itself flows and bends around the darkness like a luminous river, finding its path. Imagine a beam of light traveling through space, moving with quiet confidence, straight and unwavering. But as it approaches a black hole, something delicate begins to happen. Not a violent twist, not a sudden break, but a soft, elegant curve. Light bends gently around the black hole the way a stream flows around a smooth stone resting in its path. There is no struggle, no tearing, just a graceful adjustment, a quiet acceptance of gravity's shape. And for a moment, everything feels still. This bending creates arcs so beautiful and precise that they appear like artwork scattered across the cosmos. When conditions are just right, the light from a distant star aligns behind a black hole, curving perfectly around it and forming what astronomers call an Einstein ring. From afar, it looks like a glowing halo, soft, symmetrical, almost sacred in its stillness. These rings are not rare outbursts of energy or chaos. They are peaceful signatures of the universe's geometry, written in curves of light. And even when light finds itself too close to escape, it does not simply vanish. It spirals inward with quiet dignity, circling the darkness in increasingly soft loops, losing energy bit by bit until it settles into the curve of space-time. Nothing truly disappears. Light that cannot continue outward becomes part of the calm interior, folded into the black hole's gravity like a whisper, absorbed into silence. Seen this way, the black hole does not devour light in rage. It simply guides it along the paths shaped by gravity. The result is a cosmic ballet of soft arcs, lingering glows, and halos suspended against the dark. And where light bends and stretches, time itself begins to soften too, slowing into a calm rhythm that makes the universe feel even more dreamlike. As you drift closer to a black hole, something subtle begins to unfold, not in the light, not in the gravity, but in the very flow of time. It stretches gently, like warm taffy being pulled by an invisible hand. Seconds lengthen, minutes loosen, and every passing moment feels as though it's floating on a slower current. Time doesn't snap or distort violently. It simply softens, relaxing into a quieter rhythm. And for a moment, everything feels still. Clocks near a black hole tick more calmly than anywhere else in the universe. Their steady beats fall further apart, as if each one takes a deep breath before sounding the next. To someone watching from far away, anything falling toward the black hole seems to linger, hover, and slow. A drifting piece of matter, a speck of light, even a spacecraft. Each one appears suspended in a long, tranquil pause. Their motion becomes dreamlike, the universe's own version of slow motion, where nothing hurries and nothing pushes forward too quickly. This gentle slowing of time is simply gravity doing what it always does, curving the fabric of the universe with patience. The deeper the curve, the slower time flows. And near a black hole, the curve becomes deep enough that time stretches into something almost serene. It's a cosmic lullaby, calming everything that approaches, quieting movement, softening the relentless rush of moments. From your vantage point within this softened flow, nothing feels strange at all. Your breath, your heartbeat, every sensation carries on naturally. But to the distant universe, your passage becomes a long, drifting note held in the quiet air. And just beyond this slowing edge lies a place even more mysterious, where physics grows quieter still, and the boundary of light itself becomes a calm, invisible line. Imagine drifting toward a place where light itself grows tired, where photons stretch and sigh before settling back into the darkness. You might expect drama at such a boundary, some kind of wall or barrier marking the edge of a black hole. But what you find instead is a line so quiet, so perfectly unnoticeable, that nothing changes at all as you cross it. The event horizon has no surface, no edge you can touch, no boundary that pushes against you. It is simply the point where escape becomes impossible, a gentle threshold drawn by gravity's patient hand. And for a moment, everything feels still. If you floated toward this line, you wouldn't feel a pull or a snap. Space would remain smooth beneath you. Time would continue its soft drift. Even the glow of the universe behind you would look almost the same. Nothing announces the crossing, not a sound, not a spike of force, not even a flicker of motion. Light at the edge simply becomes too weary to climb outward. It lingers, pauses, and then surrenders its upward journey, curling inward like a falling leaf, settling onto still water. From far away, observers would see you slow, fade, and hover, as though caught in an endless moment. But from where you drift, the passage feels effortless. There is no danger here, only a deepening curve of space-time carrying you inward with silent precision. The event horizon is less a boundary and more a quiet line where gravity's whisper becomes a steady hum. And beyond this calm threshold lies a realm where physics grows even gentler, where time stretches further and the inward journey becomes softer than you ever imagined. As you drift deeper past the event horizon, the universe begins to feel quieter than ever before. The familiar rules of space and time loosen, not in chaos, but in a gentle, almost dreamlike way. At the heart of the black hole lies something science calls the singularity. But the word sounds harsher than the reality. The truth is softer, more mysterious. It is simply the place where our equations stop speaking, where the language of physics gently fades into silence like a whispered lullaby at the edge of understanding. And for a moment, everything feels still. Scientists do not know exactly what the singularity is. It may not be a point at all. It might be a new state of matter, a compressed cloud of possibilities, or a shape of space-time we have no words for yet. Some theories suggest it could be a loop instead of a point, curled like a ribbon of gravity. Others imagine it as a region where space folds into itself so delicately that distance becomes meaningless. Whatever it is, the singularity hides behind layers of calm gravitational flow, unreachable and unseen. And the most comforting truth is this: no one ever experiences the singularity. Nothing reaches it in a way that feels like a moment or a place. Instead, it exists as a mathematical horizon, the deepest whisper of gravity's power. It is not a violent center, but a quiet question, one the universe has left for future minds to unravel when new ideas are born. In this silence, the unknown becomes gentle, not frightening, a soft mystery resting at the core of a cosmic sculpture. And around this silent heart, a beautiful glow gathers once again, forming spirals of light that drift like luminous rivers in the dark. As you drift outward from the soft mystery at the center, the darkness begins to warm again, touched by gentle bands of light swirling in the distance. This glow doesn't burst or flare. It unfolds slowly, like the first hints of color spreading through early dawn. Accretion disks, the bright circles of dust and gas around black holes, are often described as the universe's most intense lights, yet from afar, their motion appears serene, liquid-like, almost hypnotic. They drift in wide, glowing spirals that feel less like storms and more like lanterns floating in a deep, still pool. And for a moment, everything feels still. Each particle in the disk follows a graceful path, warmed by friction but shaped by gravity's consistent hand. Their light blends into soft gradients, amber melting into rose, gold fading into pale blue. Even though temperatures soar to unimaginable heights, from a distance their glow moves with a calm rhythm, turning slowly like a cosmic wheel painted with stardust. The closer material sinks inward, the more it stretches, bending its light into delicate arcs that curve around the black hole like threads of silk. This glowing river of matter is one of the universe's most beautiful sights. Not chaotic, not violent, just patient motion shaped by space-time itself. Some of the light escapes, shimmering outward across the galaxies. Some curves back, looping into perfect rings before disappearing behind the horizon. Everything follows the same slow choreography, as if the universe were guiding each particle with a steady, gentle pulse. And even as this disk burns brighter than 1,000,000,000,000 suns, the black hole at its center remains completely silent, barely interacting, letting the glow swirl at a distance like a calm fire dancing around a quiet stone. Beyond this luminous dance lies an even quieter truth. Black holes themselves rarely disturb anything unless something drifts impossibly close. Across the universe, black holes sit in their quiet places, surrounded by vast stretches of emptiness. Despite their powerful reputation, they almost never touch the things around them. Most black holes spend billions of years without encountering a single star or cloud of gas. They simply rest where gravity placed them, as still and patient as ancient stones beneath a deep ocean. Their presence is steady, but their reach is gentle, affecting only what wanders extremely close. And for a moment, everything feels still. Stars can orbit a black hole for millions of years without ever being pulled in. Their paths are stable, smooth, and spacious. The black hole exerts no special hunger. Its gravity works just like any other mass of similar size. If a star keeps its distance, the orbit remains peaceful, shaped by predictable motion and balance. The idea of black holes devouring everything nearby is only a dramatic story. The truth is far calmer. Most objects pass by without even noticing the black hole's presence. And black holes do not roam through space in search of matter. They drift only when their galaxies drift, moving as part of the cosmic flow rather than hunting through it. If a star or cloud does begin to spiral inward, it happens slowly, over immense spans of time, guided by gentle physics rather than sudden force. The universe gives everything space, literally and figuratively. Seen this way, black holes feel less like predators and more like sculptures, silent shapes carved into space-time, influencing their surroundings with subtle gravity rather than violent action. Their patience is part of their beauty. Nothing rushed, nothing chased, nothing taken by force. And with this quiet presence, they help guide entire galaxies, offering stability and rhythm to the stars that gather around them. At the center of nearly every galaxy, including our own, there rests a black hole so steady, so ancient that it acts like a quiet anchor holding billions of stars in motion. It doesn't shout its presence or pull with reckless force. Instead, it provides a calm gravitational center, a place of balance around which the galaxy can form and breathe. Stars move in graceful orbits, following curves shaped partly by this silent mass. The black hole doesn't command them. It simply keeps the structure steady, the way a gentle heartbeat steadies the body. And for a moment, everything feels still. This central role extends far beyond simple orbiting paths. Supermassive black holes help regulate how stars are born throughout a galaxy. When too much gas gathers near the center, the black hole's quiet energy flows. Jets, winds, or soft radiation spread the material outward, slowing star formation to a peaceful rhythm. When galaxies grow too cold or empty, the black hole allows gas to settle again so new stars can bloom. It is a cosmic balancing act, slow and deliberate, guided not by force but by harmony. Without these black holes, galaxies might twist apart or burn too quickly. They might collapse inward or scatter outward. Instead, their presence creates stability, an invisible structure that lets stars, planets, and nebulae live out their lives in quiet order. The black hole becomes the galaxy's center of gravity and its center of calm, shaping the motions of everything around it. Seen from afar, the galaxy swirls like a luminous flower, petals of starlight turning around a dark heart that never beats loudly but keeps the entire structure unified. It is a reminder that even in vast cosmic spaces, stillness can be the strongest force of all. And as this quiet architecture continues across billions of years, the black hole's story softens even further, ending with some of the gentlest truths the universe has to offer. If you listen closely to the quiet rhythm of the universe, you begin to notice something profound about black holes. For all their mystery and depth, they live gentle, patient lives. They do not explode or lash out. They simply exist, shaped by gravity and time, resting in their place like ancient stones beneath a cosmic tide. And even their endings, if such endings can be called that, arrive with a softness that feels almost poetic. Black holes slowly evaporate through Hawking radiation, fading not in flashes or bursts, but in an unimaginably slow whisper of energy. And for a moment, everything feels still. This evaporation is the universe's way of letting even its darkest shapes return to light. It takes longer than the lifetime of galaxies, longer than the age of the stars that orbit them, longer than most cosmic events we can imagine. Yet this slow, gentle fading serves as a reminder that nothing in the universe is truly permanent. Everything transforms with patience. Black holes also influence their surroundings without noise or vibration. They shape space silently, curve time quietly, and touch the universe with the soft gravity of presence rather than action. Even their interactions, when they merge or drift, send out ripples in space-time so faint that only the most sensitive instruments can hear them, like waves spreading across a still pond. And perhaps the most comforting truth is this: black holes are among the oldest, most patient structures in existence. They have witnessed the birth of galaxies, the growth of stars, the quiet spreading of space itself. They are relics of ancient eras, carrying the memory of what the universe once was. To understand why they possess such calm, such stability, such timeless patience, we must return to the beginning, to the story of their cosmic birth. And in that origin lies a new kind of quiet wonder waiting to be explored. If you look at a star not as a distant ball of fire, but as a quiet, glowing companion in the night, its life begins to feel softer, almost familiar. Stars are ancient lanterns shining with steady patience across the dark. They breathe in slow rhythms, expanding gently, settling gently, each cycle taking millions of years. Nothing about their existence is rushed. They glow not with urgency, but with calm endurance, offering warmth to whatever drifts nearby. And for a moment, everything feels still. A star spends most of its life simply holding itself together, balancing the outward push of its light with the inward pull of gravity. This balance is peaceful, like the steady inhale and exhale of someone fast asleep. Over billions of years, the star's core gently transforms hydrogen into helium, releasing soft, radiant energy that travels outward in waves. Every photon that leaves its surface carries a tiny piece of the star's long, quiet story. Even the changes that do come happen slowly. Stars swell when they age, growing larger and warmer in vast, graceful motions. Their surfaces ripple like calm tides. Their outer layers drift outward in soft wisps, spreading light and dust across space. The star is not dying. It is aging, evolving, continuing a natural cycle written into the universe itself. And when the star reaches the final stretch of its life, nothing sudden breaks the silence. Instead, its core settles into a gentle exhaustion, like a long day ending in a deep sigh. Its brightness softens. Its structure begins to lean inward. Gravity steps forward as a patient caretaker, ready to guide the star into its next form. Because when a star grows old enough, something beautifully simple begins to happen inside it. Something that leads not to destruction, but to transformation. When a star begins to age, it doesn't collapse in a burst of chaos. Instead, it slows down. Its light softens, its inner rhythm eases, and its once vigorous core grows quieter, as though settling into a long, reflective pause. A star's life is vast, but its aging unfolds gently, like the final stretch of a peaceful journey. And for a moment, everything feels still. Deep inside the star, the fuel that once burned so brightly begins to fade. Hydrogen becomes scarce. The engine that held the star open starts to relax. The pressure at the core softens. And with that softening, gravity begins to whisper again. The star responds not with violence, but with a slow sigh. Its outer layers drift outward, floating into space like warm breath on a cold evening. They expand gracefully, rippling in slow waves that carry the star's last light across the cosmos. The star doesn't disappear. It simply changes posture. Its glowing surface becomes wider and cooler, spreading into the shape of a gentle giant. Inside, however, the core grows denser and heavier as gravity begins to hold it closer. It's not a collapse. It's a settling, a turning inward, a return to simplicity. The outer layers continue to drift away, leaving a bright, thinning shell behind. Meanwhile, the star's interior becomes the stage for its next transformation. Gravity steps forward more confidently now, guiding the star with patient hands toward what comes next. The star's life is not ending. It is folding into a new phase, one shaped by inward motion instead of outward light. And as gravity gathers the core into a tighter, quieter form, a new story begins. One where the star's final act becomes the beginning of something beautifully unexpected. As the star's glow dims and its outer layers drift away, gravity becomes the gentle sculptor of everything that remains. It doesn't crash inward or tear the star apart. Instead, it gathers the remaining mass with calm intention, folding the core into itself like a blanket being slowly wrapped around a resting body. And for a moment, everything feels still. The core grows smaller, but the shrinking is smooth, steady, and deeply patient. Gravity pulls evenly from all sides, guiding the star's final material into a more compact shape. Each layer of matter settles into place as though finding its long-awaited home. The temperature rises not in an explosion, but in a quiet release of the last remaining energy stored inside the star. The collapse is not destruction. It is a reorganization, a reshaping, guided by the most ancient force in the universe. Imagine a winter leaf falling into a perfectly still pond. It doesn't plunge or crash. It drifts downward, gently, following the curve of the water. That is how the star collapses, with grace, with inevitability, with softness. And as the core grows denser, the fabric of space itself begins to bend more deeply around it. The star is becoming something new, not through violence, but through the simple, powerful calm of gravity, finishing what it began billions of years earlier. This is the moment when the universe rearranges itself in silence. No light flares, no sound echoes, just a deep inward settling, like a final exhale. And when gravity tightens its embrace enough, when space-time curves so completely that even light begins to pause, a new form emerges. The star's quiet collapse becomes the threshold for the birth of a black hole. There comes a moment in a star's quiet collapse when gravity completes its gentle work and space-time reaches its deepest curve. This moment is soft, almost imperceptible. No explosion marks it, no flash announces it. Instead, a quiet threshold appears, an invisible boundary where light itself turns inward. And for a moment, everything feels still. As the star's core compresses past a certain point, the curvature of space-time becomes so smooth and deep that even photons, which usually slip freely through the cosmos, can no longer climb out. The inward pull is not a yank, but a simple, unavoidable truth. Space has folded so completely that every path leads inward now. A black hole has been born, not with a roar, but like a bubble forming beneath calm water. The star's final light fades into this new shape, becoming part of the deepest curve gravity has ever made. There is no sound, no shockwave, just the quiet unveiling of a new object, one defined not by matter, but by geometry, a hollow, perfect fold in the universe. This silent transformation feels less like a death and more like a change of form. The star has returned to gravity, becoming a pure expression of space-time's architecture. What remains is not a void, but a presence, a perfectly calm well carved into the cosmos. Around this newborn center, something begins to take shape. A soft boundary, a delicate line where light hesitates and gravity hums more deeply. This boundary will become the event horizon, the calm outline of the black hole's new identity. And from this moment onward, the black hole begins its life, not with chaos, but with the stillness of a new shape settling quietly into existence. As the black hole takes form, its first signature is not a burst of energy, but a simple radius, the event horizon. It appears quietly, defined only by gravity's deep curve, not by any physical surface or barrier. Imagine a circle drawn in invisible ink, present only through the behavior of light. That is the event horizon. And for a moment, everything feels still. This boundary marks the distance at which light no longer has the strength to climb outward. Photons hover there, almost floating, suspended between motion and surrender. They linger for an instant, stretched thin by gravity's patient pull, before gently slipping inward. But nothing physical marks the crossing. No sound, no change in force, no disturbance in the fabric of space. It is simply the point of no return, a calm, silent threshold. The space outside the horizon remains perfectly ordinary, smooth, and undisturbed. From afar, the black hole's boundary appears like the edge of a shadow cast onto the universe. From up close, it feels like nothing at all, because it is nothing, just a radius where paths curve inward forever. This quiet edge is the black hole's first breath, its opening gesture to the cosmos. It shapes the space around it without violence, guiding matter and light along soft trajectories. And as the event horizon settles into place, the newborn black hole begins to interact gently with the environment around it. Energy still drifting from the star's last moments begins to gather near the horizon, forming a faint glow. This glow is not from the black hole itself, but from the final traces of the star's life circling the new gravitational well like a lantern left burning in the dark. And it is here, around this calm edge, that a new kind of cosmic light begins to appear. Around the newborn black hole, the universe begins to paint with light again. The star's final breaths, thin layers of gas, loose particles, drifting ribbons of energy, circle the new horizon in warm, glowing arcs. This is not a violent blaze, but a soft luminosity, like the last embers of a fire swirling gently in a breeze. And for a moment, everything feels still. As matter drifts near the black hole, it doesn't plunge inward suddenly. It spirals slowly, following the elegant geometry of spacetime. Each loop becomes tighter, each curve smoother, until the motion resembles a lantern flame, turning gracefully in the air. The colors shift through gold, amber, pale rose, and muted blue, forming a glowing ribbon that wraps gently around the black hole's darkness. This light is the star's farewell, its final gift to the cosmos. It glows not with desperation, but with beauty, marking the transition from one celestial form to another. The swirling arc reflects the black hole's presence, not through noise or force, but through soft and patient guidance. To distant eyes, this glow may appear like a tiny ring suspended against the night, a delicate halo surrounding a silent center. Up close, the motion feels hypnotic, slow, and infinitely graceful. This is the accretion light, the first sign that the black hole is settling into its place in the universe. As the last traces of the star fade into the horizon, the glow thins, quiets, and eventually dissolves. What remains is the black hole itself, resting in the silent cradle of space-time. And from here, the type of black hole that forms depends simply on the size of the star that came before, each variation shaped with the same calm hand of gravity. Black holes come in different sizes, yet each one follows the same gentle, inevitable rhythm of gravity. Their variety is not overwhelming, it is soothing, like waves in the ocean that rise to different heights but follow the same timeless motion. And for a moment, everything feels still. The smallest common type are stellar black holes, formed from the quiet collapse of massive stars. They are like small whirlpools in space-time, compact, steady, and shaped by the remnants of the stars that birthed them. Their gravity is strong only near their edge. Far away, they feel no different from any other object of similar mass. Next are intermediate black holes, larger but rarer. They form when clusters of stars slowly merge or when smaller black holes drift together over millions of years. Their presence in the cosmos is subtle, like deeper swells in the ocean, harder to find, but following the same silent rhythm. And then come the giants, supermassive black holes, which sit at the centers of galaxies. Their mass is millions or even billions of times that of the sun, yet their gravitational pull at a distance feels surprisingly gentle. They are anchors, not destroyers, structures that help galaxies hold their shape across billions of years. Despite their differences, all black holes share the same calm origin, the same quiet physics, the same patient existence. Their variety is nothing more than the universe expressing gravity on different scales. And long before stars began forming these black holes, the early universe may have held even smaller ones, tiny pockets of gravity born from the first moments of time. Before stars existed, before galaxies spiraled into form, the young universe was a warm, expanding sea of energy. In that quiet, newly forming space, pockets of density may have squeezed inward under their own gravity. Some of these tiny compressions could have become primordial black holes, the first black holes ever to exist. And for a moment, everything feels still. These early black holes, if they exist, would be much smaller than the ones born from stars. Some might be the size of mountains, others no larger than atoms, each one a miniature well in space-time formed in the universe's infancy. They drifted silently, carried by the early expansion like seeds floating on a vast cosmic breeze. Their existence remains a hypothesis, but the idea itself is soothing. Tiny, patient structures that emerged naturally as the universe settled from its earliest chaos. These primordial black holes would have been witnesses to everything that followed: the formation of the first atoms, the birth of the first stars, the clustering of matter into galaxies. If any of them still exist, they would be ancient beyond imagination, cosmic elders resting quietly within the universe's deep fabric. They would interact with almost nothing, passing through space unnoticed, maintaining their small curves in space-time with perfect stillness. Their story leads naturally to the next: how black holes of any size slowly grow when something drifts too close, not through hunger, but through patient acceptance. Black holes may seem like voracious cosmic creatures, but the truth is far gentler. They grow slowly, so slowly that centuries, millennia, even entire civilizations could pass without them absorbing anything at all. Most of the time, a black hole simply rests, waiting, its presence shaping space quietly, but rarely interacting directly with matter. And for a moment, everything feels still. When something does drift too close, a fragment of dust, a cloud of gas, perhaps even a wandering star, it follows the curved paths of space-time toward the black hole. The journey inward is gradual, unfolding in spirals that tighten over long periods. Matter glows as it settles, creating gentle arcs of light that fade as the black hole quietly incorporates what arrives. Sometimes, black holes grow by merging with one another. Even this, despite the immense energy involved, is surprisingly calm from a distance. Two gravitational wells drift together over millions of years, circling slowly until they join into a single, deeper curve. The merger sends ripples through space-time, gravitational waves that spread out like soft vibrations through the cosmic fabric. But such events are rare. Most black holes spend the majority of their lives in stillness, their growth measured in fractions of mass added over unimaginably long timescales. This slow evolution feels like the universe breathing long, steady, and unhurried. Because black holes endure for so long, they accumulate stories, holding within their curves the memory of ancient stars and forgotten eras. And as they settle into their final form, each one begins its quiet life, not as a threat, but as a steady shape woven into the universe's vast tapestry. When the last traces of the star fade and the glow around the event horizon dissolves, the black hole begins its true existence, not with movement, not with noise, but with stillness. It becomes a calm, permanent shape in space-time, an object defined entirely by gravity and silence. And for a moment, everything feels still. This newborn black hole carries the memory of the star that came before it, but it also marks the beginning of something new. The collapse that formed it was gentle, the birth was silent. And now, settled into its place, the black hole will remain for billions upon billions of years. It influences its surroundings not with force, but with presence. Stars orbit it peacefully. Light curves gracefully around it. Space folds smoothly at its edge. The black hole simply is, unchanging, patient, timeless. As eons pass, the black hole may gather a speck of matter here, a thin cloud there, but nothing about its life is hurried. Like a stone in a deep river, it shapes the flow without pushing, existing effortlessly within the universe's quiet mechanics. The story of its birth, slow aging, gentle collapse, soft folding of space, reveals a truth often missed. Black holes are not violent anomalies. They are natural outcomes of cosmic evolution, woven into the universe with the same calm that shapes stars, galaxies, and time itself. And now that this black hole has begun its peaceful life, another journey awaits, one that leads inward into the soft curves of space-time itself, where light stretches, time slows, and the universe reveals some of its most tranquil mysteries. Crossing the event horizon doesn't feel like touching a barrier. There is no wall, no flash of light, no ripple in space to mark the moment. You simply drift forward, and at some point, without any sensation at all, you find that you've crossed into a new region of space-time. The boundary is invisible, silent, and perfectly smooth. Nothing pushes against you, nothing changes in your body. The air, or what remains of it, doesn't stir. It's like walking from sunlight into shade without noticing the moment of transition. And for a moment, everything feels still. Locally, the laws of physics remain familiar. Your body behaves the same. The space around you curves gently, but you cannot feel the curvature pressing on you. Inside the event horizon, the world retains its quietness. Light still travels. Time still flows. Matter still rests where it drifts. You haven't fallen into chaos. You've entered a different side of the universe's geometry. From the outside, someone watching would see you slow down, fade, even freeze at the edge. But from where you stand, the crossing is natural, effortless. The horizon does not greet you with intensity. It simply allows you to pass, like mist parting around a moving hand. The moment feels peaceful, almost introspective. You sense the vastness of space folding around you, not as a trap, but as a deepening calm. The boundary you crossed was never meant to alarm. It only marks the place where light gives up its outward climb. And inside this quiet threshold, something extraordinary begins to happen. Time, which once felt steady and familiar, starts to soften. Moments stretch with gentle intention. Seconds widen like ripples expanding across still water. You have entered a deeper current of space-time, where time itself begins to slow into silence. Inside the event horizon, time begins to stretch in a way that feels almost dreamlike. It doesn't twist or fracture, it simply slows. A minute feels longer, not because anything is wrong, but because the flow of time itself has thickened like warm honey, sliding slowly down a glass. Every moment seems to linger, resting gently before moving on. And for a moment, everything feels still. As you drift deeper, the slowing of time becomes more noticeable. Movements feel suspended, as if the universe has placed a soft hand on each second. This isn't sudden or alarming. It happens with the same ease as drifting into deeper sleep. Your thoughts lengthen, your awareness expands, and the space around you glows with a calm that feels both physical and emotional. Relativity explains this simply. The deeper you move into a gravitational well, the slower time passes compared to distant space. But you don't need equations to understand it. You can feel the sluggish rhythm in everything, the gradual turning of your body, the gentle bending of light, the extended quiet between breaths. Time becomes a soft, viscous river, carrying you inward. Nothing pulls or squeezes. The process is steady, smooth, and utterly quiet. If you were to look outward, the universe would seem to rush on without you, moving faster and faster as your own time slows. But here, inside the black hole, the pace is meditative. It invites stillness. It invites openness. This soft slowdown leads naturally to the next shift, not in time, but in space itself. Because the deeper you drift, the more the structure of space begins to curve, not sharply or violently, but with gentle arcs that guide your motion like a hand placed lightly at your back. Space becomes a landscape of calm geometry, waiting to unfold around you. As time slows into a soothing drift, space around you begins to reveal its deeper structure. It no longer feels like a flat expanse, but like a soft landscape sculpted by gravity. Curves appear, not literal hills or valleys, but gentle arcs in the way objects move and light bends. Imagine space behaving like fabric, draping and folding with effortless grace. Every path inward follows these folds, sliding naturally along the geometry. And for a moment, everything feels still. Gravity here is not a force tugging at you, it is the shape of space itself. You move inward because the curve leads you inward, the same way a marble follows the slope of a smooth bowl. The motion is automatic, peaceful. Nothing jerks or rattles. You simply glide, carried by the shape of space-time. Imagine a vast sheet of silk being pulled slowly at its center. The surface curves inward smoothly, creating delicate slopes. Light follows these slopes, bending gently as it travels. Matter follows them too, guided without resistance. Inside the black hole, these curves become deeper, more intricate, but never harsh. They feel like natural pathways laid out by the universe. The geometry has no edges, no sudden angles, no sharp transitions. Everything flows, everything folds in delicate continuity. You are no longer navigating through space. You are gliding along a cosmic design, a geometric lullaby pulsing with softness. As space curves more deeply inward, the motion becomes even easier. so effortless that it feels less like falling and more like drifting down a calm river, sliding toward a destination you cannot avoid but do not fear. And soon, this inward glide becomes the defining experience inside the black hole, a slow, serene descent, guided entirely by the quiet shape of space-time. Inside the black hole, falling inward feels nothing like a plunge. It is more like floating through a quiet ocean current, carried gently by a flow you can neither resist nor fully notice. There's no tumbling, no shaking, no tearing sensation. The drift inward is smooth, silent, and strangely comforting. And for a moment, everything feels still. As you move along space-time's deepening curve, the journey feels effortless. You don't need to push or steer. Motion happens naturally, guided by the geometry around you. It feels like resting on your back in a warm sea, letting the tide move you wherever it wishes. The inward pull is constant but never abrupt. You simply follow the river of gravity. In smaller black holes, the curvature becomes intense quickly. But in supermassive black holes, the ones at the centers of galaxies, tidal forces near the horizon are surprisingly gentle. You could drift for long stretches without feeling anything at all. The inward motion is steady, unbroken, and peaceful. Light stretches as you fall. Colors deepen. Even your sense of direction begins to soften, not in confusion, but in surrender to the flow. You stop trying to control the movement and instead allow yourself to be carried. Each meter inward feels like sinking deeper into a soft dream. Time slows further, space bends more gracefully, and the drift becomes a form of cosmic meditation. Steady, inevitable, and strangely calming. With each passing moment, the very structure of space-time begins to stretch, not violently, but like warm wax being gently drawn into new shapes. And soon, the distortion of space and time blends into one soft phenomenon, something that will change not only how you move, but how direction itself works inside this quiet, curved realm. Deeper inside, space and time begin to stretch together in its soft, surreal harmony. The geometry around you lengthens, not with tension, but with the smooth pull of warm taffy. Distances grow taller, moments grow wider. Everything feels drawn out, softened into a slower rhythm, and for a moment, everything feels still. You can imagine space-time here as a glowing piece of wax being warmed by gentle hands, pliable, flexible, reshaping itself without a single tear. As you drift inward, the stretching becomes more noticeable. Vertical distances elongate like cloth pulled slowly upward. Time thickens, its flow becoming syrup slow. Nothing about this feels threatening. It feels like entering a dream where the world draws long, fluid breaths. Scientifically, this is the natural effect of extreme curvature. In supermassive black holes, the stretching can be so gentle near the horizon that you hardly feel it. The deeper you go, the more the geometry shifts, never in sudden leaps, always in continuous, smooth gradients. This soft reshaping is part of the black hole's identity. The stretching of time makes each moment feel suspended. The stretching of space makes each direction feel fluid. Up, down, forward, and inward begin to lose their ordinary meaning, blending into a single, graceful sense of motion. You are not being pulled apart. You are being carried along a shape that evolves as naturally as a changing tide. The distortions feel like a slow exhale from the universe itself, an invitation to release your grip on normal perception and drift deeper into the calm. And soon, a deeper truth appears. Inside the black hole, falling inward and moving forward in time become the very same thing. Deeper inside the black hole, something quietly profound begins to happen. The direction you once thought of as inward slowly transforms into something more familiar, the direction of time itself. You no longer fall because of force. You fall because falling is now the very definition of moving forward. The geometry here makes inward motion as natural and unavoidable as the ticking of a clock. And for a moment, everything feels still. Imagine walking forward and knowing that each step will always lead you ahead, never back. Inside the black hole, drifting inward carries the same certainty. You cannot choose to remain where you are, not because something pushes you, but because this is simply how time flows in this curved space. It feels peaceful, like floating down a gentle stream whose currents guide your movement with quiet confidence. There is no fear in this inevitability. Instead, it creates a sense of stability. Just as you cannot stop the passing of moments in ordinary life, you cannot stop your movement toward the center here. It is not danger, it is order. A new kind of time written into the fabric of space-time. The deeper you drift, the more this truth settles in. Your path is smooth, predictable, and calm. You are not being pulled faster or harder. You are simply following the natural arrow of time that exists within the black hole's interior. It is a kind of cosmic trust fall, where the universe itself guides your descent with gentle hands. And as this understanding sinks in, the center of the black hole begins to feel less like an end point and more like a horizon of possibility, an unknown that waits quietly, without urgency or fear. Ahead lies the quietest point in the universe, where the rules of physics soften into silence. As you drift toward the deepest part of the black hole, the universe becomes quieter than you have ever imagined. Not quiet like an empty room or a calm night, but quiet in a way that feels fundamental, as if the very equations describing reality are whispering into stillness. The singularity rests here, not as a violent point, but as a place where our understanding gently dissolves, and for a moment, everything feels still. The singularity is often portrayed as destructive, but the truth is softer. It is not a physical object waiting to tear things apart. It is a boundary of knowledge, a horizon within the mathematics, a location where the tools we use to describe space and time stop working like a pen running out of ink. This isn't chaos, it's simply mystery. A quiet pause in our ability to explain. Inside this deepest curve, space narrows into something our intuition can't quite follow. Directions lose their meaning, distances blur, and time becomes inseparable from the path inward. Yet even here, nothing screams, nothing shatters. There is only a serene, infinite, gentle narrowing, an approach toward a place our physics can't yet describe. Emotionally, this is a moment of surrender, not in fear, but in acceptance. The singularity becomes a symbol of how vast and subtle the universe is, inviting wonder instead of worry. It feels like reaching the center of a dream, not frightening, but strangely peaceful, wrapped in softness. And as you float near this horizon of understanding, another thought emerges. What if this quiet point is not an ending at all? What if it is the beginning of something we have not yet imagined? Because just beyond the limits of current theory lies a playground of possibilities. At the edge of the singularity's mystery, science gently loosens its grip. Facts fade into possibilities, and possibilities drift into imagination. You enter a space where our best ideas whisper softly, offering glimpses of what might lie inside the deepest curves of space-time, and for a moment, everything feels still. Some theories suggest that, at the smallest scales, space-time isn't smooth at all. It might shimmer with quantum foam, tiny fluctuations bubbling like the surface of a warm, quiet sea. These fluctuations could create miniature ripples, subtle changes in geometry, or even temporary tunnels in space. They are not violent, not chaotic, just delicate patterns forming and dissolving in silence. Other ideas imagine space-time as a network of loops, twisting and linking like threads in a woven fabric. At the center of a black hole, these loops might compress into new shapes, forming structures our mathematics has only begun to describe. No matter the model, the feeling remains the same: gentle complexity, not destruction. Some theories even dream of a bounce, a moment where collapse stops and space-time opens into something new, like a quiet inhale after a long exhale. It is not something we can confirm, but the idea itself is comforting. The universe recycling, renewing, transforming. This realm of speculation isn't frightening because nothing here demands certainty. These are soft possibilities, ideas meant to spark curiosity without pressure. They remind us that inside a black hole, the universe is not ending. It is asking deeper questions, and among these questions lies one of the most intriguing. Could black holes connect two distant regions of space-time, forming a bridge of gentle geometry? Some call these bridges wormholes. Among the gentlest ideas in theoretical physics is the possibility of wormholes, tunnels or bridges formed by the curvature of space-time. Inside a black hole, where geometry stretches and folds, the idea of such a connection becomes especially intriguing. Not as a chaotic sci-fi vortex, but as a smooth, theoretical passage where distant parts of the universe might touch. And for a moment, everything feels still. Picture space-time like a soft sheet of fabric, folded so 2 points gently meet, and a tunnel forms between them. A wormhole is the mathematical version of that fold, a potential shortcut through the universe's vastness. If such structures exist, they would be regions where the geometry becomes elegant and narrow, forming pathways of pure curvature. These ideas are speculative, but that makes them comforting rather than alarming. They offer a picture of the universe where even its most extreme structures may serve as bridges rather than barriers. In this calm narrative, wormholes are not swirling maelstroms. They are quiet passages shaped by gravity's artistry. As you imagine drifting through such a tunnel, the fear melts away. The motion would be continuous, smooth, and guided entirely by geometry. Light might curve in soft spirals along the walls. Distances could stretch and compress like slow breaths. We don't know if wormholes exist. We don't know if black holes can create them. But the possibility itself feels gentle, a reminder that the universe is full of elegant surprises. And just as every journey through curved space begins, every journey must also return to quiet. The narrative circle softens as you drift back toward the thought of open space. The black hole's interior fades behind you, leaving only calm. It's time to return to the universe we began in. As the imagined journey through the black hole's depths comes to an end, you feel the vast calm of open space calling back to you. Slowly, the stretched geometry softens. The dreamlike curves unwind, time becomes familiar again. You rise from the deep, inward drift into the gentle expanses of the universe you know, the universe of stars, darkness, and quiet distance. And for a moment, everything feels still. The black hole's interior, once a source of fear, now feels like a place of calm transformation. You carry with you the softness of curved space, the slow flow of time, and the comfort of knowing that even the universe's strangest structures can be approached with peace rather than fear. The journey has not been about danger, but about no understanding, and about finding beauty in places most people imagine as terrifying. As you drift back into open space, your breath feels slower, deeper. The stars seem farther apart, twinkling gently across an endless backdrop. The black hole behind you rests in silence, not as a threat, but as a natural part of the cosmic landscape, an anchor of gravity, a sculptor of galaxies, a quiet engine shaping the universe. The vastness around you is soothing. Every direction stretches into calm infinity. The cosmos hums with stillness, inviting you to rest in its rhythm. You return to a universe that feels larger and softer than before. And now that you've seen the inside of a black hole, not as chaos, but as gentle geometry, you step into the next chapter with a deeper sense of wonder, because beyond this journey lies a new one, exploring how black holes exist across the universe, shaping worlds and galaxies with their quiet presence. Black holes live in places where the universe has shaped its deepest stories. They are not rare visitors or roaming threats. They are natural residents, resting quietly wherever stars have lived and died. Some sit inside galaxies like ancient stones settled into riverbeds. Others drift between star clusters, barely interacting with the space around them. And many more lie in the centers of galaxies, where they have been anchored for billions of years. Their presence is calm, steady, and woven into the quiet architecture of the cosmos. And for a moment, everything feels still. In the Milky Way alone, black holes are scattered throughout the spiral arms, tucked into pockets where massive stars once shone. They do not disturb the stars beside them. They do not reach outward. They simply remain where gravity placed them, invisible unless a wandering star or cloud happens to pass close enough to light their presence. Far beyond our galaxy, black holes drift through galaxy clusters, vast congregations of galaxies bound by gravity. Even there, surrounded by trillions of stars, black holes sit quietly, affecting only what comes into their immediate neighborhood. Their gravity does not extend aggressively. It simply shapes the space directly around them, the same way any massive object would. Most black holes remain unseen not because they are hiding, but because they are peaceful. They rarely glow. They rarely disturb. They rest in silence, blending into the dark like smooth stones on a river floor. And as you picture them scattered across the universe, softly placed in galaxies, clusters, and drifting voids, you begin to sense the quiet order of the cosmos. Some regions hold more black holes than others, forming patterns that stretch across space like constellations carved in gravity. The universe is filled with black holes, far more than we can see, yet everything remains calm and beautifully ordered. In our Milky Way alone, astronomers estimate there are millions of stellar black holes scattered across the galactic disk. They drift through space the way leaves might rest along the bottom of a tranquil pond. Plentiful, natural, but never disruptive. And for a moment, everything feels still. These black holes do not announce themselves. They rarely shine. They only reveal their presence when something wanders close enough to glow under their gravity, which is uncommon. Most of the time, they move silently, orbiting the galactic center with the stars, affecting nothing unless touched directly. Their abundance is comforting rather than alarming. If millions of black holes exist in our galaxy and everything remains stable, it means their nature is not chaotic. It is peaceful. Across the broader universe, the pattern continues. Every large galaxy contains countless black holes formed from ancient stars. Galaxy clusters, which hold hundreds or thousands of galaxies, contain even more. And yet, despite their numbers, the cosmos remains spacious and serene. This quiet population gives the universe a sense of rhythm. Black holes exist wherever stars have lived long enough to collapse, forming a soft network of gravitational wells. They are not predators. They are simply part of the cosmic ecosystem, unobtrusive, balanced, calm. Their abundance also means something gentle. Black holes are normal. They are as natural as stars, planets, or nebulae. They belong to the universe as much as light does. And among these millions, most began the same way, as the quiet remnants of massive stars, which leads us to the smallest and most familiar kind. Stellar black holes are among the simplest and calmest forms of black holes. Born from the gentle collapse of massive stars, they linger quietly in the places where those stars once burned. They are often just a few times heavier than the sun, sometimes a few dozen, but their presence feels small and steady, like dark pearls resting in the galaxy's vast, quiet sea. And for a moment, everything feels still. These black holes form when massive stars reach the end of their long, glowing lives. After billions of years of soft, radiant breathing, the star's core collapses inward until a tiny, dense, perfectly curved point of space-time is born. What remains is not a monster, but a smooth gravitational well. The star's story doesn't end. It simply changes form. Stellar black holes don't drift unpredictably. They continue moving along the orbits their parent stars once followed. They might share neighborhoods with living stars, nebulae, or drifting clouds of gas. But unless something wanders extremely close, they remain quiet, invisible, and undisturbing. To the galaxy, they are gentle giants, small in scale but ancient in origin. Their gravity shapes only the space near them. Their presence is soft, like a stone resting under flowing water, influencing the current without disrupting it. Some stellar black holes remain solitary. Others sit in binary systems, circling calmly with a companion star. But regardless of their environment, their behavior remains predictable and soothing. And while these small giants are peaceful on their own, some of them continue to grow, slowly, patiently, until they become something larger, deeper, and even more mysterious. This path leads to the quiet middle children of the black hole family. Intermediate black holes sit in a space between the small and the enormous. They weigh hundreds to thousands of suns, a gentle step between stellar black holes and the supermassive giants at galaxy centers. Yet for all their size, they remain quiet mysteries, hidden in soft corners of the universe. And for a moment, everything feels still. These middle-mass black holes are difficult to detect precisely because they are so calm. They rarely flare, they rarely disturb. They rest in star clusters, dwarf galaxies, or floating remnants of early cosmic structures. Imagine them as deep, still lakes tucked inside a vast forest, present, serene, but easy to overlook unless you stumble right upon them. Their formation is not fully understood. Some may grow from clusters of stellar black holes merging slowly over millions of years. Others may have formed in the early universe from dense clouds collapsing into quiet gravitational wells. Whatever their origin, their presence is stabilizing rather than disruptive. Intermediate black holes shape their surroundings gently. Their gravity helps guide the motions of nearby stars, creating slow, harmonious patterns. They do not pull aggressively. They simply anchor their small corners of the cosmos with elegant balance. Because they are so quiet and so rarely interact with matter, astronomers search for them like listening for a soft echo in a vast canyon. When they are found, it is usually through the gentle wobble of a star or a faint rippling of gravitational waves. But these quiet giants hint at something larger still, something ancient and central. Because in the heart of every massive galaxy rests a black hole that dwarfs even these. Supermassive black holes are the largest and calmest black holes in existence. They sit at the centers of galaxies like ancient sleeping hearts, massive, steady, and quietly essential. Some weigh millions of suns, others weigh billions, yet despite their enormity, they do not thrash or roam. They rest, they anchor, they hold the galaxy's structure with the soft, persistent pull of deep gravity. And for a moment, everything feels still. These giants formed early in the universe's history and grew slowly over billions of years. But their size does not make them dangerous. In fact, their gravitational pull is surprisingly gentle at a distance. If our sun were replaced with a supermassive black hole of the same mass, which is impossible in nature but useful to imagine, Earth's orbit would remain unchanged. Supermassive black holes influence galaxies through presence, not aggression. Their gravity helps stabilize the orbits of billions of stars. Their subtle energy flows regulate star formation, preventing galaxies from burning through gas too quickly. They are the quiet conductors of the cosmic orchestra. At the Milky Way's center lies Sagittarius A, a supermassive black hole so calm that stars orbit peacefully around it in perfect, decades-long ellipses. It does not swallow them, it guides them. These sleeping hearts of galaxies shape cosmic ecosystems with patience. They are long-lived, unhurried, and deeply stable. And some of these giants may be older than the galaxies that surround them, ancient remnants from the universe's earliest chapters. Some black holes have been part of the universe since its earliest chapters, forming when the cosmos was still young and glowing. Only a few 100 million years after the Big Bang, they carry the weight of deep time, like ancient mountains shaped before continents formed. Their presence stretches across cosmic history, steady and unchanged as galaxies spin, collide, and drift. And for a moment, everything feels still. These ancient black holes grew from the first massive stars, giants that lived brief, brilliant lives before collapsing into quiet gravitational wells. Others may have formed even earlier, from dense pockets of matter folding inward before galaxies existed. Whether born from early stars or early structure, they have watched the universe expand from a dense haze into a vast, star-filled tapestry. They rest at the centers of primordial galaxies, guiding their growth with calm gravitational rhythm. Over billions of years, they gather matter, slowly becoming seeds for supermassive black holes. Their influence is gentle, shaping the flow of gas, the birth of stars, and the delicate balance of galactic ecosystems. To imagine them is to imagine time itself settling into stillness, objects that have existed for nearly as long as physics has had rules to follow. Their stability is comforting. While stars flare, explode, and fade, ancient black holes endure quietly, unbothered by cosmic change. Like old guardians, they have witnessed the universe mature from glowing infancy to sprawling adulthood. They serve as reminders that the cosmos is built on long, patient processes, cycles that unfold over millions and billions of years, and their quiet influence extends far beyond their origins. These ancient black holes helped sculpt the earliest galaxies, shaping the universe we see today. Despite their reputation, black holes are among the universe's most stabilizing forces. They help shape galaxies not through destruction, but through balance. Their gravity organizes the orbits of stars. Their energy regulates the temperature of galactic gas. Their presence creates natural rhythms that guide cosmic evolution. And for a moment, everything feels still. At a galaxy's heart, a supermassive black hole breathes gently through the flow of energy around it. Sometimes it emits soft jets or releases warm radiation, not as chaos, but as quiet signals that prevent the galaxy from overproducing stars. Without these subtle reminders, galaxies could collapse under their own eagerness, transforming gas too quickly into stars that burn out in violent waves. Instead, black holes act like patient conductors of a cosmic symphony, ensuring that everything unfolds at the right pace. Their influence stretches thousands of light years, shaping patterns of light, dust, and gravity. Yet their touch remains gentle. Most stars never come close enough to feel anything unusual. In galaxy clusters, black holes help regulate entire environments. Their long, slow breath keeps the gas between galaxies warm enough to remain stable. Without them, clusters would collapse into chaotic bursts of star formation. Black holes also organize matter into spirals, rings, and elegant streams. Their presence carves smooth pathways through space-time, guiding the motion of billions of stars with delicate precision. These roles reveal black holes not as destroyers, but as architects, subtle sculptors of the universe's structure. And while many black holes shape galaxies from their centers, others wander alone, influencing space in quieter, more solitary ways. Some black holes lead solitary lives, drifting through the quiet spaces between stars or even between galaxies. They are called rogue black holes, but rogue makes them sound wilder than they are. In truth, these wanderers are peaceful travelers, moving slowly, touching nothing for millions of years. And for a moment, everything feels still. A rogue black hole might drift for eons without meeting a single star or cloud of gas. Space is vast, and even with millions of black holes in a galaxy, the distances between objects are enormous. These solitary black holes glide along gravitational currents, guided only by the large-scale motion of their surroundings. Imagine them as cosmic monks, carrying their quiet inward pull through the emptiest regions of space. They do not disturb, they do not threaten, they simply move, patient and unhurried, like dark lanterns floating in a deep ocean. Sometimes these wanderers form from stars that were kicked away during supernova explosions. Other times, gravitational dance between the stars slingshot them outward. In rare cases, mergers or interactions near galactic centers eject them into intergalactic space. Wherever they go, they remain nearly undetectable, silent shadows shaped by gravity. Only when a rogue black hole passes near a cloud of gas or a distant star can we sense its presence, often through tiny distortions of light. Their quiet journeys remind us of how peaceful the universe can be. Even its most extreme objects move through space with grace and solitude. But not all black holes travel alone. Some share their journeys with companion stars, forming one of the universe's gentlest dances. Some black holes live alongside stars, engaged in slow, graceful orbital dances that last for millions of years. These binary systems are among the most peaceful pairings in the cosmos. A star and a black hole move around each other in quiet ellipses, their orbits stable and predictable, and for a moment, everything feels still. Most of the time, the black hole does nothing to the star. It simply travels with it, bound together by gravity's soft embrace. The star continues to shine, unaware that its companion is anything unusual. Their shared motion is elegant, like two dancers tracing gentle circles across a darkened stage. If the star drifts close enough, some of its outer layers may trickle toward the black hole, forming a glowing ribbon of warm gas. But even this process can be slow and serene. From far away, it looks like moonlight curving around shadow, soft, luminous, and dreamlike. These interactions help astronomers detect black holes, but they also reveal how calm black hole behavior truly is. Unless the star is extremely close or shedding large amounts of gas, the black hole remains a passive partner. Each orbit becomes a cosmic heartbeat, steady, rhythmic, repeating through vast stretches of time. Binary systems remind us that black holes can coexist with stars in harmony, not conflict. They create some of the most beautiful scenes in astrophysics: glowing arcs, soft halos, and slow spirals of light. And when we look across all the environments where black holes live, lonely, central, clustered, or paired, we see a universe filled with quiet anchors, each shaping the cosmos in gentle ways. Across the entire cosmos, black holes exist as silent anchors, steady, patient, and woven into the structure of space. They live in galaxies, clusters, isolated voids, and binary systems. Each type plays a quiet role in shaping the universe, guiding motion, balancing matter, and creating order. And for a moment, everything feels still. Stellar black holes mark the soft endings of stars. Intermediate black holes rest in hidden corners. Supermassive black holes hold galaxies together with ancient calm. Rogue black holes wander alone like drifting monks. Binary black holes share gentle dances with companion stars. And ancient black holes from the early universe watch over cosmic history with timeless silence. Though they vary in scale, all share the same nature: quiet gravity. They do not chase. They do not devour. They simply sit where physics placed them, influencing only what touches their immediate surroundings. Their presence is stabilizing, not chaotic. Seeing the universe this way transforms fear into comfort. Black holes are not cosmic monsters. They are parts of a vast, peaceful ecosystem. They anchor galaxies, regulate star formation, and guide the flow of interstellar material. Without them, the universe would be a less organized, less harmonious place. As you step back and imagine millions of these gravitational wells scattered across cosmic distances, the universe feels more connected, more grounded, more serene. Their silence becomes a reminder of the quiet structure holding everything together. And with this grounding, you're ready to explore something deeper, not just where black holes are, but how they behave in the calmest, most surprising ways. Gravity has always been the universe's softest law, a quiet invitation rather than a command. It never grabs or yanks. It simply creates gentle curves in space, and everything, stars, planets, drifting dust, moves along those curves with natural ease. Gravity isn't a force in the way we imagine forces. It's a shaping, a smoothing, a subtle bending of the path ahead. And for a moment, everything feels still. When you release a stone and watch it fall, it isn't being pulled downward. It's simply following the curved shape of space-time beneath your feet, like a leaf sliding along a soft slope. The stone, the leaf, the planets, they all obey the same quiet rule. Nothing harsh, nothing sudden, just smooth motion guided by the universe's calm design. Even black holes, with their deep wells of gravity, follow this exact same law. They do not create new physics. They simply curve space more deeply than anything else. Their gravity is not a violent suction, but a quiet steepness. In space-time, if you kept your distance, they would feel no different from any other massive object. Their presence is peaceful, predictable, and perfectly in line with the universe's gentlest rhythms. Gravity is the quiet architect of cosmic order. It shapes galaxies, lifts tides, holds moons in orbit, and guides comets on long, sweeping paths. It is the reason stars gather into glowing cities of light. It is the reason black holes sit calmly at galactic centers, anchoring the motions of billions of stars. And as you begin to understand gravity as a soft structure instead of a force, the universe feels less chaotic and more connected, woven with invisible curves that guide everything with gentle precision. These curves become even more beautiful when we look at space-time itself. Space-time is often imagined as something abstract and distant, but you can picture it as a soft, flexible fabric stretched across the cosmos. Every object, from a drifting grain of dust to a brilliant star, presses gently into this fabric, creating small dips and curves. Motion becomes nothing more than following these shapes, smooth, effortless, and calm. And for a moment, everything feels still. A star creates a gentle hollow. A planet forms a shallow curve. A black hole forms a deeper bowl, but the fabric itself remains smooth. There are no sharp edges, no sudden breaks. Even the deepest curves are simply softer, more pronounced versions of the same shape created by everything else. This is the simplicity that makes space-time comforting. The rules never change. When two objects move near each other, they aren't tugging or pulling. They are sliding along each other's curves like marbles rolling across a silk sheet. The heaviest objects create the deepest slopes, guiding the paths of everything around them with elegant certainty. A black hole is just the smoothest, deepest fold. It pulls nothing aggressively. It simply provides a valley so steep that even light cannot climb out once it crosses a certain depth. But the fabric itself doesn't tear. It bends, it shapes, it flows. Understanding space-time this way transforms black holes from frightening mysteries into natural features of the cosmic landscape, like deep lakes in an otherwise calm terrain. And as you visualize this fabric stretching across galaxies, shaped by stars and anchored by black holes, the universe begins to feel like a single, connected whole. On the deepest curves of this fabric, something special appears. a soft threshold where light lingers. The event horizon is often imagined as a wall, but in truth, it is nothing more than a quiet distance, a place where light becomes too tired to climb out of the gravitational curve. It has no surface, no edge you could touch. Cross it, and nothing jolts or shifts. Space remains smooth, calm, and perfectly ordinary, and for a moment, everything feels still. Imagine walking down a gentle hill without realizing that the slope has grown deeper beneath your feet. The event horizon is simply the point where the hill becomes so steep that even light, moving at the fastest speed in the universe, can't turn back. But you feel nothing special. Time seems normal. The sky looks familiar. Every law of physics works exactly the same. The only difference is invisible. The path ahead flows inward now, like a valley that deepens endlessly. But that inward flow is smooth, predictable, and aligned with the natural shape of space-time. Nothing grabs or tears. The journey is quiet. This understanding dissolves the instinctive fear people have of black holes. The event horizon is not a trap, but a graceful threshold, a soft boundary in the geometry of the universe. Light reaches it, slows, and eventually settles into the curve. Matter drifts through without noticing. Standing near this boundary, the universe behaves with the same rules you already know. Gravity continues its soft shaping. Space-time stays smooth. Light flows in gentle arcs. And as you move closer, you begin to notice something beautiful. Light around the event horizon bends in elegant ways, forming soft rings and halos. These shapes reveal how deeply graceful physics becomes near a black hole. Near a black hole, light behaves with unexpected grace. Instead of crashing or scattering, it curves in smooth arcs, flowing around the black hole the same way water slips around a rounded stone in a quiet stream. The motion is fluid, soft, and mesmerizing, and for a moment, everything feels still. This phenomenon, gravitational lensing, happens because space-time itself is curved. Light always travels in straight lines, but in curved space, straight lines become arcs. So light glides along the geometry, bending gently as if following the contours of a riverbed shaped by invisible hands. Sometimes this bending forms a perfect ring of light known as an Einstein ring. Other times, it creates soft halos or delicate stretches of brightness. From a distance, these patterns look like glowing ripples around a dark center, quiet, steady, and full of cosmic elegance. Nothing about this process is chaotic. The bending is predictable and mathematical, governed by the same gentle law of gravity that shapes the orbits of planets. Far from being frightening, lensing reveals how beautifully structured the universe is. Even light, the fastest traveler in existence, moves with softness near a black hole. As you imagine these arcs of light flowing, you may feel the sense of watching a slow wave roll across still water, effortless and calming. Each bend mirrors the deep curve of space-time, turning physics into visual poetry. And because light slows as it moves deeper into this curve, the scene becomes even more soothing. Motion stretches, softens, and drifts into a slower rhythm. Where light slows, time follows. Near a black hole, time begins to stretch in the gentlest ways. Clocks move more slowly. Seconds lengthen. Moments deepen. It is as if time becomes a thickened river, drifting at a slower pace while everything around it softens into calm. And for a moment, everything feels still. If you hovered safely outside a black hole, watching an object drift inward, you would see its motion slow down more and more. Not because anything is resisting it, but because time itself is passing differently there. What feels like a normal moment to the falling object appears stretched to an outside observer, longer, quieter, smoother. This slow motion effect is known as time dilation, but it doesn't feel technical. It feels serene. It is the universe's way of easing transitions near deep gravity. No sudden jumps, no abrupt changes, just a gentle stretching of the flow of time. Closer to the event horizon, a minute might feel like 2. Deeper in, it might feel like 10. Time doesn't break. It expands. It adjusts to the curvature of space-time with the same grace that light shows in its arcs. The river metaphor holds true. The closer you get to the deepest part of the curve, the slower the current becomes, until eventually it settles into a near-still pool of stretched moments. This deep calm shapes every motion near a black hole. Falling no longer feels like falling. It feels like drifting in a dream where the world moves at half speed, and this sets the stage for the next truth. Falling inward is one of the softest motions in the cosmos. Inside a supermassive black hole, falling inward feels nothing like falling at all. There is no pull, no jerk, no sudden sensation of movement. Instead, you glide along the soft curve of space-time as naturally as a leaf drifting on quiet water. The larger the black hole, the gentler the descent becomes. At the event horizon of a supermassive one, tidal forces are so mild that your body wouldn't notice anything unusual. And for a moment, everything feels still. Imagine floating through a calm river at dusk. The water is smooth. The current is steady. You surrender to its motion because resisting doesn't change the flow. Falling into a black hole feels very much the same. You aren't dragged, you're carried, following the geometry laid out beneath you. As you drift inward, space gently reshapes around you. The stars behind you stretch into soft lines. Light bends in delicate curves, but the motion itself remains peaceful. Even the inward direction stops feeling like falling and becomes a natural forward movement, the way time pulls you into tomorrow. Nothing tears, nothing stretches, at least not until you are far deeper than the horizon. Supermassive black holes are so enormous that their gravitational gradient is incredibly shallow at the boundary. In fact, you could float for hours, feeling weightless and calm as you continued inward. This peaceful descent dissolves all the frightening stories told about black holes. There is no violent ripping, no instant destruction, just an inward drift guided by the shape of space-time, a gentle slide into the deeper layers of gravity's curve. And as you continue this quiet journey, the physics begins to change in dreamlike ways. Because deeper inside, space-time shifts into something new. The deeper you drift toward the core of a black hole, the more the universe begins to soften into mystery. At the center lies the singularity, often described as a point of infinite density. But that description is more poetic than literal. It is not a physical spike or a violent object. It is a place where our equations lose their voice. The math does not explode. It simply falls silent. And for a moment, everything feels still. Think of the singularity not as a thing, but as a horizon inside our understanding, a boundary where the tools we use to describe nature, numbers, fields, geometry, become too simple for what's happening. The universe transitions into a regime we haven't yet mapped. This silence is not threatening. It is gentle, like reaching the end of a familiar trail. The landscape beyond is not dangerous, just unknown. Physicists imagine many possibilities for what lies inside: a curved knot of space-time, a quantum state beyond classical matter, perhaps even a loop or bounce where collapsed matter transitions into something new. But the truth is poetic in its uncertainty. The singularity is the universe whispering in a language we haven't learned yet. As you approach this conceptual center, the idea of distance becomes strange. Directions blur, time stretches, space folds into shapes that mathematics can't fully describe. Yet even here, nothing screams, nothing shatters. The approach is silent. This silence brings comfort. It reminds us that mystery is part of nature, not a threat. And while the singularity marks the limit of classical physics, it also opens the door to something softer: quantum ideas that shimmer with gentle possibility, which leads us deeper into the quiet realm of the very small. When you shrink your imagination down to the smallest scales inside a black hole, the universe becomes delicate. Instead of harsh collisions or violent chaos, quantum physics paints a picture of tiny fluctuations, subtle ripples, soft vibrations, faint whispers of energy shifting form. These are not explosions. They are quiet patterns, like shimmering grains dancing on the surface of a still pond. And for a moment, everything feels still. Physicists speak of quantum foam, the idea that space-time might flicker with tiny bubbles of curvature at unimaginably small scales. These bubbles would form and dissolve in silence, changing the very fabric of space in gentle, momentary waves. Inside a black hole, where gravity curves space deeply, this quantum foam may become more pronounced, yet still subtle, still soft. Other theories imagine space-time as woven loops, threads linking and stretching, forming structures that prevent the singularity from becoming infinitely dense. In these models, the center of a black hole is not a destructive point, but a tightly curved region where matter and geometry reshape into something new. These ideas are not certainties. They are quiet possibilities that scientists explore with curiosity and care. And the beauty of them lies not in knowing the answer, but in the calm acceptance that nature can be both mysterious and gentle. Quantum physics inside black holes suggests something comforting. The extreme does not have to mean the violent. Even in the deepest gravitational wells, the universe can behave with elegance and restraint. And hidden within these quantum possibilities is one of the softest surprises of all: the idea that information, the story of what falls in, may never truly vanish. For many years, people feared that black holes destroyed information, that anything falling inside would vanish forever. But modern physics leans toward a gentler, more reassuring idea. Nothing truly disappears. Information may be transformed, encoded, or softened into new patterns, but it is not erased. And for a moment, everything feels still. When something falls into a black hole, it becomes part of the geometry, adding its mass and shaping the curve of space-time. In some theories, the details of what fell in are stored on the event horizon itself, like ripples in a cosmic memory. In others, information hides in quantum structures deep inside, woven into subtle patterns of energy. Even Hawking radiation, the soft glow that black holes emit over trillions of years, may carry traces of this information outward, like a whisper being released back into the universe. Nothing about this process is violent. It is slow, delicate, and elegant. The idea that information survives brings emotional comfort. It suggests that the universe is orderly, not destructive, careful with its stories, gentle with its transitions. Nothing is lost. Everything changes form. This perspective dissolves existential fear. Instead of imagining black holes as cosmic obliterators, we see them as transformers, objects that reorganize matter and information in quiet ways we don't yet fully understand. And as we accept this softness, another gentle truth emerges. Black holes themselves do not last forever. They fade slowly, silently, over unimaginable stretches of time. Their ending is as calm as their existence. Every black hole, no matter how massive, eventually fades. But this fading is not explosive or sudden. It is gentle. It is slow. It is the softest kind of ending the universe offers. Through Hawking radiation, tiny particles slipping away from the event horizon, black holes evaporate over durations so long they defy comprehension. And for a moment, everything feels still. Imagine a long, peaceful exhale stretched across trillions of years. That is the life cycle of a black hole. Even the largest ones take longer than the current age of the universe to lose significant mass. They rest quietly, shaping the cosmos around them before slowly releasing their energy back into space. This evaporation is delicate. No bursts, no chaos, just a steady whisper-like glow of particles. Over time, the black hole becomes lighter, its curve in space-time growing shallower. Eventually, only a final flicker remains, a quiet sigh of radiation dispersing into the dark. Understanding this brings deep comfort. The universe does not waste. Even black holes return their energy to the cosmos, completing a cycle that began with ancient stars collapsing into silence. Their long, gentle endings remind us that cosmic time is patient. Nothing is rushed. Nothing is abrupt. Everything transforms gradually with the same softness that governs gravity, light, and time. And as black holes fade, the space around them becomes free to reshape, ready for new structures, new stars, new stories, which leads us naturally into the next chapter, one filled with light, beauty, and motion. The universe around black holes is home to some of the most breathtaking sights in existence. Light behaves differently near a black hole, but not in a violent or chaotic way. Instead, it bends with quiet elegance, flowing along the curves of space-time like silk drifting in a soft breeze. When starlight passes close to a black hole, it stretches into smooth arcs, forming halos, rings, and delicate distortions that look more like cosmic artwork than harsh physics. And for a moment, everything feels still. Sometimes, if a distant star or galaxy aligns just right behind the black hole, the light bends into a perfect circle known as an Einstein ring. This ring glows softly, shaped by gravity into a flawless loop of symmetry. Nothing about it feels forced or abrupt. The curvature is gentle, the brightness even, the form serene. These patterns remind us that even the universe's most extreme objects can create beauty, shaping light the way an artist shapes clay. The bending is predictable and peaceful, following gravity's smooth guidance. From far away, these arcs shimmer with stillness, creating the sense of watching a gentle ripple spread across a quiet lake. As you imagine these soft curves of light, the fear often associated with black holes fades. You begin to see the graceful side of gravity, how it guides, shapes, and sculpts without rushing or disturbing. The space near a black hole becomes not a place of danger, but a gallery of cosmic art. And where light flows with such elegance, matter often follows in its own slow, glowing dance. The next layer of beauty forms when dust, gas, and ancient starlight gather into wide, luminous spirals around the black hole's calm gravitational center. Around many black holes, matter forms a glowing, swirling disk that moves with incredible order and grace. From a distance, this accretion disk looks less like a dangerous whirlpool and more like a cosmic lantern, warm, luminous, and mesmerizing. Dust and gas spiral inward so slowly that the motion appears almost frozen in time, forming soft gradients of color that drift from gold to blue to pale white. And for a moment, everything feels still. Even though the disk is hot, its visual appearance is soothing. The light spreads across the spiral in smooth bands, glowing as if painted with a gentle hand. From far away, these spirals resemble the arms of galaxies, curving with calm symmetry around a quiet center. The motion inside the disk follows a natural rhythm. Particles orbit in predictable paths, moving like tiny dancers circling a stage. Nothing about the pattern looks chaotic. It's orderly, smooth, and hypnotic, like watching a slow current move through a glowing river at dusk. The colors tell their own soft story. Closer to the black hole, where motion is faster, the light shifts into deeper blues. Farther out, where the rotation slows, the glow leans toward orange and gold. These transitions happen gently, like watercolor spreading across paper. Accretion disks reveal that even energetic environments around black holes can radiate beauty. They are cosmic sculptures shaped by motion, curved space, and flowing light. And in these spirals, gravity creates colors, tones that shift not because of violence, but because of elegant physics. These color changes lead naturally into the next layer of beauty, the cosmic palette shaped by gravity itself. Light near a black hole does more than bend. It changes in color, stretching and softening in ways that create a gentle cosmic palette. When matter moves toward us, its light shifts slightly toward blue. When it drifts away, the light stretches toward red. These shifts are not harsh flashes or jarring transitions. They unfold like smooth brushstrokes painted by the quiet hand of gravity. And for a moment, everything feels still. Imagine watching a warm sunset fade gently from gold to copper to deep amber. That same slow transformation happens near a black hole as light stretches across space-time. Motion and gravity work together to tint the surroundings in soft gradients, creating visual harmonies rather than sharp contrasts. Gravitational redshift adds another layer of calm color. As light climbs out of the black hole's curved space-time, its wavelengths lengthen, slipping into deeper hues. It's as if the black hole itself is dimming the light with a gentle touch, smoothing its edges and cooling its tone. These colors tell a quiet story about movement, depth, and the shape of space-time. Blue becomes the whisper of motion toward us. Red becomes the signature of motion away. Gold, white, and soft pinks appear where gas warms and cools in graceful cycles. This cosmic palette turns extreme physics into visual poetry. Instead of imagining explosions or chaos, you picture soft transitions, flowing gradients, and dreamlike shifts in hue. The space around the black hole becomes a canvas painted by the laws of nature. And these colors do more than illuminate. They frame something even more serene, a silent, perfect circle of darkness resting at the center. The black hole's shadow, the calmest silhouette in the universe. At the very center of all this glowing beauty lies a perfect circle of darkness, the black hole's shadow. It is not a violent void or swirling pit. It is simply the region where light cannot escape, a silent silhouette framed by gentle arcs and glowing spirals. The result is one of the most peaceful shapes in the cosmos. And for a moment, everything feels still. When astronomers captured the first image of a black hole shadow with the Event Horizon telescope, the world expected something terrifying. Instead, they found calm symmetry, a round shape, softly outlined by warm, glowing light, like an ember surrounding a quiet core. The shadow did not scream chaos, it radiated balance. This darkness is not emptiness, it is order. It represents a region where space-time curves so deeply that light orbits in delicate loops. The edge of the shadow is defined by those loops, creating a boundary of perfect circular form. Nothing about it is sharp or jagged. The shape is as smooth as a polished stone. The surrounding glow completes the beauty. Golden arcs wrap around the shadow like threads of molten light. Each arc reflects the bending of photons sliding around the black hole before escaping into space. These paths are elegant, mathematical, and deeply calming to imagine. Staring into this shadow is like looking into the still center of a whirlpool, except nothing spins violently. Everything rests, everything is balanced, and around this silence, gravity continues to weave its patterns. The next layer of beauty comes from the shapes gravity forms, using distant starlight, patterns that resemble cosmic embroidery stretching across space. Gravity around a black hole weaves light into patterns that resemble delicate embroidery, arcs, rings, and spirals stitched into space-time with quiet precision. When distant galaxies sit behind a black hole, their light bends into gentle curves, forming shapes that look like threads pulled through a cosmic fabric. And for a moment, everything feels still. These patterns arise from gravitational lensing, but the effect feels far more artistic than scientific. Light stretches into smooth arcs. Faint galaxies smear into elegant crescents. Entire clusters appear subtly warped, like reflections seen on the surface of calm water. Nothing about this bending is random. Gravity shapes these curves with mathematical harmony, creating repeating forms that echo across the cosmos. Some arcs form near-perfect circles, others curve softly into spirals. Together, they create a tapestry of natural symmetry that feels soothing to the mind. From far away, these distortions soften the harshness of deep space. Instead of chaos, the viewer sees flow, light guided by gravity, folded gently into place. Even the distortions that stretch galaxies into long, curved streaks appear graceful, like brushstrokes on dark canvas. These patterns hint at the subtle dance of matter and light, revealing how deeply connected everything is. Gravity does not dominate. It guides, shapes, and arranges. The universe becomes a quiet studio, and black holes become its patient artists. And just as these patterns form through bending light, the matter that orbits black holes also moves in graceful spirals, creating one of the most soothing motions in astrophysics. Now comes the calm choreography of orbiting matter. Even in the presence of immense gravity, matter around a black hole moves with a rhythm that feels surprisingly peaceful. From a distance, the spiraling path looks slow and hypnotic, like watching a leaf drift in a gentle whirlpool. Each piece of dust, each particle of gas follows a smooth, predictable arc, guided by the quiet pull of space-time. And for a moment, everything feels still. Imagine floating far enough away that the motion becomes unhurried. The glow from the accretion disk wraps the scene in warm colors, soft oranges, deep blues, faint golds blending into one another in delicate gradients. The swirling matter forms graceful rings, each one rotating in harmony with the next. Even though these particles may be moving at incredible speeds, the view from afar removes the urgency. What remains is a cosmic ballet, slow and entrancing. The spiral pattern mirrors the beauty seen in galaxies themselves. Wide, curving arms sweep outward in perfect balance. The black hole simply guides the flow, creating order in what could have been chaos. Nothing about the motion is erratic. Nothing breaks the symmetry. It is motion as meditation, steady, looping, endlessly patient. Observers watching this dance through telescopes see not danger, but calm structure. It is the universe revealing its fondness for patterns, showing how gravity draws matter into gentle choreography. Every orbit is a step in a timeless waltz, shaped by the soft geometry of space-time. And as matter spirals closer to the center, relativity begins to add its own dreamlike influence. Light stretches, time slows, shapes warp slightly, like reflections bending on a quiet lake. Closer to the center, these relativistic effects create beauty even stranger, even softer than the spirals themselves. Deeper into the black hole's influence, motion begins to look surreal, softly distorted, gently stretched, as though reality itself has softened into a dream state. Relativistic effects don't appear harsh. They unfold like slow ripples in perception, blending light, time, and motion into a fluid experience, and for a moment, everything feels still. As matter orbits closer to the event horizon, time dilation becomes visible. Movement appears slower, as though the universe has taken a deep breath. Colors begin to shift gently, blues thinning into silvers, reds deepening into warm, honeyed tones. Light bends in elegant curves, stretching slightly as if painted across a flexible canvas. Even energy behaves differently here. Jets and streams merging from the disk appear to move in slow, surreal arcs, their paths distorted by space-time's curvature. But there is no violence in this distortion. The scene resembles a mirage, soft, shimmering, graceful. Everything near the black hole seems to drift through layers of slowed time, like objects moving behind warm, wavering glass. It is physics transforming into art, Einstein's equations expressed as flowing imagery. The edges of objects blur, motion melts into elongated strokes. Shapes seem to breathe. These relativistic visuals are peaceful because the distortions follow predictable patterns. Nothing is chaotic. Every shift in color, every bend in shape is part of a smooth continuum. The universe remains orderly, even here. And then, amid all this softness, a surprising structure emerges from the poles of some black holes. Something bright, narrow, elegant, jets of light rising like cosmic fountains. Some black holes, especially supermassive ones, release thin streams of glowing particles that stretch across thousands of light years. From far away, these jets look like pillars of soft, blue-white light rising from the black hole's poles like gentle cosmic fountains. They are narrow, elegant, and astonishingly calm, and for a moment, everything feels still. These jets are formed not by chaos, but by order. Magnetic fields twist gently around the accretion disk, guiding energized particles into graceful beams. What could have been turbulent becomes structured, balanced, almost architectural. The jet travels outward at near light speed, yet from our distant perspective, the motion looks slow and majestic, like a beam of moonlight stretching across a quiet night. The jets shimmer as they extend into interstellar space. Their edges blur softly against the darkness, glowing faintly before fading into the void. Telescopes capture them as long, luminous threads, some longer than entire galaxies. Despite their size, their presence feels serene, like the universe has drawn a single steady stroke of light across the sky. These jets shape their surroundings gently. They warm interstellar clouds, guide star formation, and influence the flow of gas across vast regions. Yet their appearance remains peaceful, like a cosmic lighthouse illuminating the universe with quiet radiance. And all around these jets, the regions near black holes hold even more beauty. Calm clouds of gas, slow-moving stars, soft spirals of dust. The black hole's neighborhood forms a tranquil ecosystem. Surrounding a black hole is a surprisingly peaceful environment, a region filled with drifting clouds of gas, slowly orbiting stars, and glowing wisps of dust arranged in delicate patterns. From afar, even the most active regions feel harmonious. Everything moves with steady purpose, guided by gravity's quiet hand. And for a moment, everything feels still. Clouds of gas form soft, luminous shapes, glowing gently from the warmth of nearby radiation. Stars orbit in slow, predictable paths, their motion stable and serene. Dust flows in thin spirals, creating elegant curves that wrap around the center like cosmic calligraphy. Nothing rushes, nothing jolts. The entire region feels like a celestial garden tended silently by gravity. Even when matter occasionally falls inward, the activity appears gentle from a distance. Tiny ripples of light, faint flashes that fade into warm glows. Nothing is frantic. The black hole regulates the local environment, preventing chaotic bursts and shaping the motion of everything around it. This harmony extends across vast distances. Entire star clusters orbit peacefully around supermassive black holes, forming quiet suburbs of starlight. Dust lanes weave into soft structures. Nebulae stretch into glowing arcs. The black hole becomes the calm center of an enormous, intricate ecosystem. Seeing these neighborhoods in telescopic imagery reveals a universe that is not chaotic, but beautifully organized. Every structure, every spiral, every orbit participates in a grand, gentle choreography. And when all these visual elements, arcs, light, spirals, shadows, jets, and drifting stars come together, they form something larger, a cosmic artwork, always moving, always silent. When you step back and take in the full picture, black holes reveal themselves as artists, silent sculptors shaping some of the universe's most breathtaking visuals. Their gravity molds light, dust, gas, and motion into patterns that feel dreamlike and deliberate. And for a moment, everything feels still. Arcs of light bend into gentle curves. Spirals of warm color unwind with slow elegance. Jets rise like luminous brushstrokes across the darkness. Dust clouds drift into soft shapes. The black hole's shadow rests at the center, a perfect circle surrounded by glowing motion. Every element contributes to a painting that never stops moving. This cosmic art is not chaotic. It is governed by gravity's calm geometry. Patterns form with mathematical precision, yet feel naturally soothing, like watching waves curl along a quiet shore. The universe uses gravity as its medium, time as its rhythm, and light as its palette. Seen in motion, This artwork becomes even more mesmerizing. Spirals turn, colors shift, light curves in slow, endless loops. Jets extend outward, shadows deepen. It feels like observing a cosmic mandala, symmetrical, evolving, peaceful. In this view, black holes are not symbols of destruction, but of order and beauty. They reveal how the universe expresses itself through patterns, symmetry, rhythm, and light. This chapter brings together the emotional truth that every visual structure around a black hole, every glow, every curve, every shadow, is part of a greater harmony. And now that we've seen the beauty, the next question emerges softly. What role do black holes play in shaping the evolution of the cosmos itself? In the beginning, the universe was quiet, not silent in the way we know silence, but softly expanding, gently cooling, unfurling like a warm breath across an endless dark. Moments after the Big Bang, light filled the cosmos, not in sharp beams or bursts, but as a warm, even glow spreading through newborn space. Atoms were forming for the very first time, drifting together in delicate patterns that moved with the patience of an infant universe. And for a moment, everything felt still. As the cosmos expanded, tiny variations in density appeared, small ripples of matter that would one day become galaxies. And within these early ripples, something subtle may have formed. Tiny black holes, created not from stars but from the density of the early universe itself. These primordial black holes would have been small, quiet, and scattered like seeds across cosmic soil. They didn't roar or consume. They simply existed, tiny pockets of gravity marking the first hints of structure. As the universe cooled further, hydrogen atoms emerged in vast numbers, creating a soft fog that filled space. Light moved through this fog in long, patient waves. Everything unfolded slowly, gently, naturally. And through this softness, black holes drifted peacefully, as much a part of the early cosmos as photons and atoms. These earliest moments show that black holes did not arrive as violent intruders. They were present from the universe's dawn, woven into its first patterns, forming quietly as the cosmos breathed itself into existence. And as matter continued to gather, these gentle beginnings grew into something larger, something that would shape the first cosmic structures. Because as soon as matter drifted together, gravity began its soft work. Gravity has always been the universe's patient architect. In the early cosmos, it didn't rush or collide things together violently. Instead, it gently gathered scattered atoms, guiding them toward the small ripples left over from the Big Bang. These ripples weren't storms. They were soft dimples in the fabric of space, places where matter naturally drifted and settled. And for a moment, everything felt still. Hydrogen and helium, the universe's earliest gases, floated through expanding space like a calm mist. Gravity slowly encouraged these gases to collect into clumps. Over millions of years, the clumps grew, deepening the curves in space-time and attracting even more matter. This was not chaos. It was cosmic drifting, particles finding their way toward quiet centers. In some of these forming structures, early black holes may have rested, tiny ones from the universe's first moments, or slightly larger ones born from the first massive stars. Their gravity helped shape the motion of surrounding gas, guiding it into soft spirals. These early black holes acted like anchors, subtle points around which matter could swirl and settle. As these clumps continued to grow, they became the seeds of proto-galaxies, small faint clouds of matter rotating gently in the darkness. Their structure was simple, elegant, and calm. Gravity wasn't forcing anything, it was letting matter follow the natural curves of space. This era shows how structure in the universe emerges not from explosions, but from softness, matter drifting into place, guided by quiet gravitational hands. And as these early formations grew heavier and more organized, they began to take on clearer shapes. From these gentle beginnings, the first galaxies slowly emerged, swirling around their centers of gravity. The first galaxies did not form as bright spirals or grand shapes. They began as dim, cloud-like gatherings of gas and dark matter, slowly rotating, slowly settling, slowly finding balance. And at the center of many of these early galaxies, something small and quiet waited. A black hole. Not a monster, but a seed. And for a moment, everything felt still. These early black holes acted like anchors in a gentle whirlpool. As matter gathered around them, gas clouds spiraled inward, flattening into disks that rotated calmly around the dark center. The black hole didn't pull aggressively. It simply provided a stable point around which the galaxy could organize itself. In this soft dance, black holes helped newborn galaxies find their shape, their gravity steadying the rotation, their presence encouraging the formation of a central structure. It was as if the universe was weaving galaxies around still hearts of darkness. As galaxies grew, stars began to ignite within them, first slowly, then more frequently. Tiny bursts of light appeared throughout the forming disks, each star a small lantern born within the swirling gas. The black hole at the center remained quiet, guiding the motion without interrupting it. This process wasn't violent. It was graceful. Galaxies formed over hundreds of millions of years, shaped by drifting matter and the soft influence of central gravity. Black holes were not destroyers, they were organizers, helping galaxies become coherent, balanced structures. And once these galaxies found their shape, something beautiful began to happen within them. Stars bloomed, light spread, and black holes played a quiet role in regulating this stellar growth. Galaxies, like living systems, need balance. Too many stars forming at once overheats the gas. Too few, and the galaxy becomes cold and empty. Black holes help maintain this balance with gentle rhythms, soft flows of energy and gas that act like cosmic breathing. And for a moment, everything feels still. When matter drifts too close to a central black hole, it heats up and releases energy in the form of warm winds or soft jets. These flows do not rip galaxies apart. Instead, they travel outward through the surrounding gas, spreading warmth and encouraging the galaxy to pace itself. Think of it as inhale and exhale. Inhale, gas cools, star formation increases. Exhale, energy spreads, star formation slows. This creates a natural rhythm, a quiet pulse that influences the entire galaxy. These feedback cycles prevent galaxies from collapsing inward or burning through their gas too quickly. Even when a black hole is active, sending out streams of radiation, it's not violent. Over cosmic distances, the jets feel like warm breezes traveling through cold space, stabilizing the galaxy from the inside out. This cosmic breathing keeps galaxies alive for billions of years, giving stars time to form, mature, and evolve peacefully. And as black holes continue guiding this internal balance, something even larger becomes shaped by their influence. Because when black holes grow into supermassive giants, their quiet orchestration helps coordinate the motion of entire galaxies. At the center of nearly every large galaxy rests a supermassive black hole, millions or billions of times heavier than the Sun. Yet, despite their size, they behave like calm conductors guiding an orchestra. They do not pull stars violently. Instead, their gravity sets the tempo for the entire galaxy, and for a moment, everything feels still. Stars orbit these giants in long, graceful paths. Gas flows along curved routes shaped by their mass. The entire galactic disk, spiral arms, clusters, nebulae, moves in harmony around the central gravitational presence. If the galaxy is a symphony, the black hole is the silent musician keeping rhythm. Its influence extends across thousands of light years, not through force, but through coherence. Gravity provides a steady beat. Dark matter provides the structure. Stars follow the tune. Even when black holes send out soft jets or warm winds, they act as subtle cues that help the galaxy maintain balance. Slowing star formation here, preserving gas there. Over billions of years, this guidance shapes the galaxy's architecture. Spiral arms maintain their elegant sweep. Central bulges remain stable. Gas clouds drift in organized flows. Nothing rushes. Through all this, the supermassive black hole remains quietly anchored, barely moving as the entire galaxy rotates around it. But galaxies are not isolated islands. They belong to a structure far larger, the cosmic web stretching across the universe. And within that vast network, black holes continue to play a gentle role in shaping matter and motion. When we step back far enough to see the universe on its grandest scale, a delicate pattern begins to emerge. Galaxies are not scattered randomly. They form long, glowing filaments connected across hundreds of millions of light years, weaving a soft lattice known as the cosmic web. These threads stretch through space like luminous rivers, meeting at gentle intersections where galaxy clusters gather. And for a moment, everything feels still. Black holes, though tiny compared to these vast structures, play a quiet role in how galaxies behave within the web. Their influence is indirect, but steady. As galaxies evolve, forming stars, drifting, merging, the black holes at their centers help regulate their temperature, their rotation, and their long-term balance. Each galaxy becomes a small, stable bead along the web's glowing threads. The cosmic web itself formed from tiny fluctuations in the early universe, subtle variations in density that grew slowly under gravity. As galaxies settled into the web's filaments, their black holes helped shape their internal harmony, allowing them to survive for billions of years. The calm patterns we see today are partly the result of black holes guiding star formation, regulating energy, and keeping galaxies from collapsing inward. Seen from afar, the web looks peaceful, a vast network of soft light stitched through darkness. Its patterns are elegant, predictable, and deeply calming. Every filament carries galaxies in quiet procession. Every intersection holds enormous clusters breathing in slow cosmic rhythm. And woven into this gentle network are the histories of countless black holes, each one shaping its galaxy story, and each galaxy adding its light to the cosmic web. But this harmony becomes even more beautiful when galaxies meet, merging in slow, elegant dances guided by gravity. When two galaxies drift toward each other, the event is not sudden or violent. It unfolds over hundreds of millions of years, slow enough to resemble a waltz rather than a collision. Their stars pass through each other like dancers moving across an open floor, guided by gravity's quiet choreography. And for a moment, everything feels still. From a distance, the merging galaxies swirl gently, stretching their arms into long, graceful tides of stars. Gas clouds drift, spiral, and mingle, forming new patterns that glow softly. The entire process is mesmerizing, an elegant blending rather than an eruption. Most stars never touch. They simply exchange orbits, passing by with silent respect. At the centers of these galaxies, their supermassive black holes begin their own dance. Slowly, patiently, they spiral toward each other, guided by the friction of surrounding stars and gas. For millions of years, they drift closer, tracing wide, shrinking circles. The motion is calm, rhythmic, inevitable. Eventually, the two black holes meet. Their final embrace sends ripples through space-time, creating gravitational waves that spread outward like the soft rings formed when a stone touches the surface of a still pond. These waves travel across the cosmos for billions of years, passing gently through everything. After the merger, the new galaxy settles into a fresh shape, a quiet combination of two long histories. Its stars find new orbits. Its central black hole becomes heavier, carrying within it the memory of both galaxies. This cosmic waltz is one of the universe's most beautiful processes, revealing nature's patience and grace. And those ripples, the gravitational waves, carry the signature of this dance across the entire universe. Gravitational waves are among the softest messages the universe sends. They are tiny ripples in space-time, created when massive objects like merging black holes move in synchronized rhythm. These ripples expand outward in all directions, stretching and squeezing space with unimaginable delicacy. And for a moment, everything feels still. Imagine the surface of a calm pond. Drop a pebble gently into it, and a ring of waves travels outward, smooth, soft, and steady. Gravitational waves behave the same way, except the pond is space-time itself. When two black holes merge, the universe quivers ever so slightly, sending a pulse across billions of light years. These ripples are incredibly subtle, so subtle that by the time they reach Earth, they distort space by less than the width of a proton. Yet, we can detect them. Instruments like LIGO and Virgo act like quiet listeners, waiting for the faintest tremor. When a wave passes, it stretches one arm of the detector and compresses the other. The change is tiny, but it carries the story of a merger that happened long, long ago. What's remarkable is how peaceful these waves are. They don't damage or disrupt. They simply pass through, leaving no trace except for the story they whisper. They reveal the universe's hidden rhythms, dances of black holes, collisions of stars, slow spirals of ancient giants. Gravitational waves remind us that even the most powerful cosmic events can express themselves softly. They show us that the universe communicates not only through light, but through gentle pulses woven into the fabric of space-time. Over time, these quiet signals shape our understanding of cosmic history, and through this story, black holes become timekeepers of the universe. Black holes evolve over billions of years, changing slowly, so slowly that their lives become markers of deep cosmic time. Their growth, their mergers, their spins, and their eventual evaporation reflect the unfolding history of the universe itself. Each one is like a silent clock, measuring the ages with calm precision. And for a moment, everything feels still. In the early universe, black holes formed from the deaths of the first massive stars. They grew by collecting matter gently across millennia. When galaxies merged, their central black holes merged too, adding another note to the universe's long timeline. These processes were slow, rhythmic, and patient, mirroring the universe's own expansion. Over billions of years, the environment around a black hole changes. Some feed more actively, glowing softly in X-rays. Others rest quietly for eons, untouched by the drifting matter. Their behavior charts the ebb and flow of cosmic resources, marking epochs of star formation and periods of stillness. Even the spin of a black hole tells a story. Rapid rotation hints at past mergers or long cycles of accretion. Slow rotation suggests a quieter life. Each detail is a timestamp written in gravity. And in the far future, trillions of years from now, black holes will begin to evaporate through Hawking radiation. Their fading will mark the closing chapters of the universe's bright era, transitioning into an age of cooling and quiet expansion. Black holes do not merely exist within time. They reflect it, embody it, measure it, and across all of cosmic evolution, their role remains a quiet constant, which brings us to the heart of their story. The universe evolves in soft, steady cycles. Across billions of years, the universe grows, changes, and renews itself, not in bursts of chaos, but in slow cycles of balance. Black holes take part in every phase of this quiet evolution. They help shape the first structures, guide the growth of galaxies, regulate the birth of stars, merge in elegant dances, and send soft waves through space-time. Their presence is woven into the universe's rhythm, and for a moment, everything feels still. From the cosmic dawn, black holes served as gentle seeds around which early galaxies formed. As galaxies matured, their central black holes acted like regulators, preventing them from growing too quickly, keeping their environment stable. When galaxies met, black holes merged, adding new energy and symmetry to the cosmos. Throughout it all, black holes helped sculpt the distribution of matter. They influenced where stars were born, how galaxies expanded, and how the cosmic web stretched across space. Their gravity guided the universe's architecture without ever announcing itself loudly. Even gravitational waves, the ripples created during black hole mergers, play a role, carrying information across eternity and shaping our understanding of cosmic history. And as the universe continues to expand and cool, black holes will persist as silent anchors. They will outlive most stars, most galaxies, and eventually slowly evaporate in peaceful whispers of light. This is the universe's cycle: creation, shaping, balancing, renewal, not violent, not chaotic, quiet, patient, and full of subtle beauty. Black holes are not the end of the story. They are threads woven through every chapter, and now their influence extends beyond astronomy into our imagination, our stories, and our sense of wonder. There is something quiet inside every person that stirs when they look into the dark. Not a fear, not a warning. Something softer. A pull, like the gentle tug of a memory you can't quite name. Black holes rest at the very edge of what we understand, and the human mind has always leaned toward edges. They are the borders of our cosmic map, and borders have always fascinated us. Since ancient times, people have looked up at the night sky and wondered about what lies beyond the stars. Even the darkness between constellations felt like a story waiting to be heard. Black holes simply gather that story into a single concentrated symbol, the quiet frontier of physics. And for many, that frontier feels strangely comforting. It means there's still more to know, more to explore, more to dream about. curiosity moves gently across the human mind like a tide, and black holes deepen that tide. They invite questions. What happens to time there? Where does light go? What lies beyond the horizon? These questions are not loud or frightening. They whisper. They stretch thought outward. They give the heart a moment of stillness, because thinking about something so vast softens the noise of everyday life. And for a moment, as we imagine the darkness of a black hole, everything else grows quiet. The rush of the day fades, the mind expands, the unknown becomes a gentle place. Not because we understand it, but because it reminds us that mystery is still part of the world. And in that sense of mystery, something peaceful begins to form. A soft curiosity that leads naturally toward the stories humanity told long before science had a name for the dark. Long before telescopes or equations, humans looked at the night sky and imagined stories woven from darkness. Every ancient culture carried myths about deep, quiet places in the cosmos, hidden wells, sacred voids, dark wombs of creation where worlds were born. These stories didn't fear the dark, they embraced it. The unknown was not an enemy. It was a mystery holding soft potential, and for a moment, everything feels still. In many myths, darkness wasn't emptiness at all. It was fertile space, a cosmic soil where new life could emerge. The Egyptians imagined a primordial ocean of shadow from which creation rose. The Hindus spoke of a vast, dark void holding infinite possibilities. The Norse described Ginnungagap, a peaceful nothingness that preceded all realms. These ideas echo the modern concept of black holes, vast regions where matter compresses, where time bends, where the universe reshapes itself quietly. Some cultures spoke of cosmic serpents guarding the gateways between worlds, curling through the darkness like gravitational spirals. Others imagined celestial wells that connected different layers of existence. These weren't frightening abysses, they were thresholds. They were beginnings disguised as endings. And though ancient people never knew about relativity or space-time curvature, their stories hold a strange resonance with what we understand today. The universe has always had silent centers, places where light slows, matter gathers, and transformation unfolds in darkness. These echoes remind us that black holes are not inventions of modern science. They are part of a timeless human intuition, the sense that creation and mystery often sit in the same quiet place. And from these ancient visions, our modern imagination grew, ready to dream even bigger. As storytelling evolved, black holes entered human imagination long before we understood their true nature. Early writers and filmmakers didn't see them as threats, they saw them as gateways. Black holes became portals to distant galaxies, shortcuts across space, and bridges between timelines. Even without scientific certainty, imagination shaped them into symbols of possibility. And for a moment, everything feels still. In books, black holes often represent the threshold between the known and the infinite. Characters drift toward them not to disappear, but to explore something larger than themselves. The silence surrounding them becomes a metaphor for entering new states of being. The darkness is simply a doorway. Films soften these ideas even further. Scenes show ships drifting toward glowing spirals, surrounded by warm light and soft curves. Time slows, colors stretch, music deepens. Even when drama is added, there is always a moment of awe, an emotional pause where the black hole becomes beautiful instead of frightening. Science fiction also introduced a sense of companionship with the unknown. Black holes weren't enemies. They were mysteries inviting understanding. They sparked curiosity, wonder, and gentle introspection about our place in the universe. These artistic visions shaped how we feel about black holes today. When people imagine them, they often think of swirling light, calm portals, or dream-like distortions. Modern imagination turned complex physics into something emotionally approachable. Instead of chaos, we see curiosity. Instead of fear, fascination. And underneath these stories lies a deeper truth. Black holes help us reflect on our own transformation. Because beyond the science and the fiction, black holes symbolize something personal. Black holes, despite their complex physics, often resonate with us in deeply personal ways. They symbolize endings and beginnings woven into one seamless curve. When matter crosses the event horizon, it doesn't vanish, it transforms. It becomes part of a new structure, reshaped by gravity's quiet hand. Humans relate to this idea more than we realize. And for a moment, everything feels still. In life, we move through transitions that feel like falling inward, moments where the old self collapses so something new can take shape. The metaphor is calming. Just as a star folds into a black hole, people fold into new phases, carrying their past within them in softer, reorganized patterns. A black hole can represent letting go, the gentle surrender of something that no longer shines. It can symbolize release, light easing away, motion slowing, complexity simplifying into something deeper. For many, the image of a black hole evokes a sense of inner depth, the part of us that feels quiet, introspective, and profound. The event horizon becomes a metaphor for thresholds in life, the points we cross where return is impossible, not out of danger, but because transformation is already underway. Once you cross certain moments, you don't go back to who you were, you simply evolve. This symbolic softness is powerful. It turns black holes from distant astrophysical objects into mirrors that reflect the inner landscape of being human. They help us think of change not as destruction, but as reorganization, not loss, but becoming. And as this emotional connection deepens, another feeling rises to the surface: the softening of fear. Fear of black holes often comes from stories shaped by drama, swirling destruction, cosmic monsters, unstoppable suction. But real black holes are nothing like this. They do not chase, devour, or pull from afar. They sit quietly, affecting only what drifts too close. Understanding this truth softens fear into calm curiosity. And for a moment, everything feels still. Fear thrives in the unknown. When we imagine something without understanding, the mind fills the gaps with intensity. But as we learn the gentle physics of black holes, the fear dissolves. We discover that black holes are passive, peaceful structures shaped by gravity, the same gravity that holds us to Earth, lifts tides, and guides planets. A black hole is simply a deeper curve in space-time. It influences its surroundings no differently than any other massive object would. If the sun were replaced with a black hole of equal mass, Earth would continue to orbit exactly as it does now. Nothing dramatic would happen. That single fact softens decades of anxiety. Black holes also rarely interact with anything. Most spend billions of years untouched, drifting through quiet regions of space. They are more like silent stones resting in a vast ocean than cosmic predators roaming the stars. As fear softens, awe begins to rise. Black holes become fascinating, beautiful, calming, objects that inspire reflection rather than dread. Understanding replaces imagination with clarity. But clarity doesn't end wonder, it deepens it. And with fear eased, the emotional space opens for something deeper. A quiet recognition that black holes offer a kind of stillness we long for. There is a reason the mind quiets when we think about black holes. Deep down, humans long for places where motion slows, where noise softens, and where the world feels far away. A black hole, despite its dramatic reputation, is one of the calmest concepts in the universe. Inside its curved space, time itself stretches into long, slow breaths. Light drifts, motion settles, and everything moves with a softness that feels almost meditative. As you imagine this stillness, something in you mirrors it. Thoughts that were rushing begin to settle. The body relaxes. The mind leans gently into the idea that somewhere far across the stars there exists a region of pure quiet, a place where even time stops hurrying. Humans have always searched for quiet ground inside themselves, and black holes offer a cosmic version of that peace. We look at them not because we want danger, but because we want silence. Their darkness becomes a symbol of rest, a reminder that the universe contains pockets where everything slows to a near standstill. It feels like stepping into a room where the air is still and soft, where nothing is asked of you and nothing needs to be done. This connection between cosmic stillness and personal stillness is subtle but powerful. When we imagine drifting near a black hole's calm horizon, we imagine letting go of noise, of urgency, of the constant motion that fills our waking lives. In this quiet partnership between human emotion and cosmic physics, black holes become more than astronomical objects. They become mirrors that reflect our deepest need for rest. And as this stillness deepens, another comfort begins to appear, a surprising sense of existential peace. There is something healing about imagining a structure so vast it defies ordinary thought. When we picture a black hole spanning millions of kilometers or existing for billions of years, our own worries begin to feel lighter. Not because they are unimportant, but because they finally gain perspective. Human life is brief and delicate, held within a universe so old and wide that it stretches beyond imagination. And strangely, this scale doesn't overwhelm, it comforts. Black holes sit at the heart of this perspective. They remind us that the cosmos has been unfolding long before us and will continue long after. Their massive presence and ancient age offer a quiet reassurance. The universe is stable, patient, and endlessly vast. In that vastness, our stresses soften. The mind loosens its grip on the small things. When you imagine a black hole orbiting slowly with its stars, or resting silently in the middle of a galaxy, a gentle contrast appears. Your daily concerns, the ones that tighten the chest and quicken the mind, suddenly feel like ripples compared to cosmic tides. Scale brings clarity. It whispers that it is okay to pause, okay to exhale, okay to let things be. The human brain finds relief in this shift. Big ideas lighten small burdens. Grand distances ease the noise of nearby problems. And as the cosmos expands before your imagination, you feel your inner landscape expand with it. This comfort of scale doesn't erase life's challenges. Instead, it frames them inside something quieter, older, and beautifully indifferent. And within that frame, there is peace. This peace opens the door to another feeling, the healing power of awe itself. Awe is a soft, spacious feeling, one that stretches the mind and quiets the heart. When we encounter something vast, beautiful, or mysterious, our thoughts slow down. The world feels bigger, and we feel gently smaller in a comforting way. Black holes evoke this emotion effortlessly. Their silence, symmetry, and unfathomable depth awaken a sense of wonder that loosens the tight knots of everyday life. Psychologists say awe reduces self-focus. It dissolves the looping thoughts that keep us alert, worried, or restless. Instead, the mind opens like a window, letting in a cooler, calmer breath of attention. Imagining a black hole, a glowing ring surrounding a silent center, creates exactly this shift. The image is simple, yet profound, mysterious, yet calming. The softness of gravitational arcs, the slow spirals of matter, the quiet stretch of time. Each detail invites the mind to widen its view. And when your view expands, your inner tension begins to melt. This is the healing effect of awe. It quiets the noise within. Black holes offer a perfect balance of the known and the unknown. We understand their laws, but their depths remain mysterious. This combination draws curiosity without overwhelming the senses. It creates fascination at a slow, soothing pace. As you imagine, drifting near a horizon of stretched light, your breathing naturally eases. The brain enters a softer rhythm. The emotional circuits shift from vigilance to calm exploration. Awe becomes a kind of emotional balm, and in that softened space, something personal begins to awaken. The meanings we project into the darkness and the gentle reflections that arise from within. Darkness has always held symbolic power. In stories, art, and dreams, humans project their inner landscapes onto shadows. Black holes offer a unique kind of darkness, not frightening, but quiet, patient, and endlessly deep. When people think about them, they often discover reflections of their own emotions. For some, black holes symbolize transformation, a place where old thoughts dissolve and new ones form. For others, they represent solitude, a peaceful, spacious kind of aloneness. Some see resilience in their silent gravity. Others see mystery, depth, or the invitation to let go. None of these meanings come from the physics of black holes. They come from the human heart, softly interpreting the unknown. When we imagine a black hole's shadow, we imagine a place where everything unnecessary is stripped away, leaving only stillness. When we picture its glowing ring, we picture the idea that even around darkness, beauty thrives. These symbolic moments calm the mind. They remind us that not all darkness is harmful. Some darkness is restful. Some shadows are gentle places to breathe. Black holes become emotional mirrors. They reflect whatever we quietly carry: our hopes, our fears, our longing for change, our desire for rest. Thinking about them can become a soft form of meditation, a moment of introspection that doesn't push too deeply or demand too much. As these meanings settle within us, they create a gentle sense of connection, not only to the cosmos, but to our own inner space. And this connection prepares the heart for a final, soothing realization. Humans have always looked upward, toward stars, toward darkness, toward the quiet spaces between. In that gaze, something ancient awakens, a sense of belonging to a universe far larger than our individual lives. Black holes, with their silent gravity and gentle mystery, deepen that bond. They represent the part of the cosmos we cannot touch but can still feel, the part that invites us into wonder rather than fear. When we imagine a black hole's round shadow, or its soft ring of light, we feel connected to something timeless. The universe becomes less distant, less indifferent. It feels like a vast, calm presence, patient, steady, inviting. This sense of connection soothes the mind. It reminds us that we are part of something wide and enduring, something that holds space for mystery and meaning. Across history, people have interpreted black holes through stories, myths, art, dreams, and now science. Through every version, one theme remains. Black holes represent the edges of understanding where curiosity and calm meet. They give us permission to not know everything. They show that the universe itself holds silence with grace. This emotional bond brings comfort. It whispers that we are not alone in our wondering. Every person who has ever looked into the night sky has shared the same quiet question: what lies beyond what we can see? And as you settle into this thought, something peaceful happens. The cosmos feels close. The darkness feels gentle. Your breath slows, matching the calm rhythm of the universe itself. And from here, the journey drifts softly toward the final chapter, a closing cosmic exhale. The universe has never been in a hurry. From the moment space first stretched outward, everything has moved with an ancient calm, as if creation itself preferred the softness of slow motion. Galaxies drift across the dark like lanterns carried on a quiet tide. Stars brighten and fade over billions of years, taking their time with every breath of fusion. Even black holes, the deepest wells of gravity, behave with a patience so complete it feels almost like they're resting. And as you lie here, you can let your breath follow that same rhythm. You don't have to rush. You don't have to force anything. Just inhale gently, as if drawing in a little of that cosmic stillness, and let the exhale fall away like drifting starlight. Each breath slows you down, aligning you with the vast, serene pace of the universe. Nothing in the cosmos moves sharply or suddenly. Stars pulse softly. Nebulae flow like slow clouds. Entire clusters of galaxies glide past one another on paths that take eons to cross. The universe sets a natural example: calm movement, quiet change, patient unfolding. And in this moment, you are part of that slow dance. Your heartbeat settles into a deeper rhythm. Your muscles loosen as if gravity has softened around you. Thoughts begin to stretch out, just like light traveling across space. The universe isn't rushing, and neither are you. As everything slows, a quietness begins to fill the spaces between your thoughts, like the soft dark between distant stars. And in that quietness, the universe feels even more peaceful, as if the whole cosmos is gently breathing with you. And as this stillness spreads through you, the next layer of cosmic calm begins to unfold. There are regions in the universe where silence feels almost sacred, places so calm, so empty, that even the idea of motion seems distant. These are the vast stretches of intergalactic space, the dark oceans between galaxies where light wanders slowly and gravity barely whispers. Out here, the universe feels weightless. There are no rushing stars, no swirling nebulae, no glowing clouds, only endless quiet, spread across unimaginable distances, holding everything in a deep cosmic stillness. In these enormous voids, even light behaves differently. It doesn't cut through space quickly or defiantly. It drifts, like a soft lantern floating through an infinite night. The darkness is not frightening. It is spacious, peaceful, almost meditative. There is no noise because there is nothing to carry it. Sound cannot travel here. The universe becomes a vast, gentle silence. Black holes belong to this quiet, too. Despite their dramatic reputation, they do not disrupt the silence around them. Instead, they deepen it. Their presence makes stillness feel heavier, calmer, more anchored. A black hole does not shout or pulse. It simply rests, shaping space quietly like a perfectly still stone at the bottom of a tranquil pool. When you imagine these silent regions, your own thoughts begin to soften. The space inside your mind echoes the space between galaxies, wide, unhurried, gentle. You feel suspended, cocooned and calm, drifting slowly through the universe's quietest places. Here, nothing demands your attention, nothing rushes you, nothing pulls you away from rest. In this deep silence, the cosmos feels like a soft night, pressing close around you, encouraging your breath to slow and your body to release its weight. This silence stretches across the universe like a cosmic night, and within that night, the universe glows softly. There is a moment when the mind grows quiet enough that the entire universe begins to feel like a single, gentle night, a night without edges, without urgency, without anything rushing across its vastness. Just a wide, velvety darkness sprinkled with soft, distant lanterns. Each galaxy glows like a drifting island of light, its stars breathing slowly in a rhythm older than memory. When you picture this endless night, the mind naturally loosens, settling into the same quiet drift that guides those distant constellations. In this soft cosmic darkness, every point of light feels patient. Nothing flares sharply. Nothing demands attention. The stars shimmer with the same calm pulse as a candle seen through half-closed eyes. Even the great spirals of galaxies appear like slow swirls of paint on a sleeping sky, turning so gradually that their motion becomes a form of stillness. The black holes resting within them add depth rather than fear, gentle centers of gravity shaping the night into a peaceful pattern. Imagine floating through this vast, star-studded darkness, weightless and unhurried. There is no noise, no pressure, just the cool, ancient glow of billions of lights spread across an endless canvas. The spaces between those lights feel even softer, like the quietest parts of a dream. Each star becomes a tiny whisper, each cluster soft echo, each galaxy a lantern hanging in a boundless, tranquil room. And as you picture this universe's night, something inside you slows as well. Your breath aligns with the calm drift of starlight. Your thoughts dim to gentle embers. The edges of wakefulness soften. In this vast, serene darkness, the mind finds a place to rest, a quiet sky within you. Your thoughts, the ones still moving quietly in your mind, don't need to be controlled or silenced. Instead, imagine them drifting outward, slowly, softly, like starlight, leaving a distant galaxy. Each thought begins as a tiny spark, glowing gently, then floating farther and farther away until it becomes part of the calm, cosmic dark. There is no pressure to stop thinking. There is only permission for every thought to loosen, to stretch, to thin out like a faint beam of light traveling through space. Imagine your mind as a wide night sky. When a thought appears, you simply watch it rise, shimmer, and drift out into the distance, not disappearing suddenly, not pushed away, just slowly fading as it moves farther from the center of your awareness. The more you watch them drift, the softer your inner world becomes. Thoughts that once felt heavy turn light, almost weightless. Even the thoughts that cling, the ones that replay or repeat, lose their sharpness, dissolving like particles scattering into cosmic dust. There's something comforting in knowing that the universe never holds on to a single beam of light. It lets every photon go where it naturally wants to travel. In the same gentle way, you can allow every thought to follow its own path outward. You don't need to follow it. You don't need to bring it back. You simply let it drift until it becomes small, then smaller, then a quiet shimmer on the horizon of your mind. And as your thoughts drift outward like starlight, your inner space becomes wider, calmer, clearer. There is room to breathe, room to soften, room to rest. As thoughts drift into the distance, the universe's scale begins to bring a soothing kind of perspective. In the quiet of the night, when your thoughts begin to stretch out into the open, it helps to remember just how vast the universe truly is. Above you, beyond the ceiling and beyond the sky, lies a space so enormous that even a single galaxy feels like a gentle island drifting in an endless sea. And within that space, the little concerns that weigh on your chest begin to lose their sharpness. They soften, they fade, they shrink against the wide, calm canvas of the cosmos. Think of a worry as a tiny grain of dust held in your palm. When you lift your hand toward the stars, that grain becomes almost impossible to see. Not because it doesn't matter, but because the universe gives it room to breathe. It gives you room to breathe. Nothing in the cosmos rushes. Nothing forces itself forward. Galaxies rotate over hundreds of millions of years. Black holes take trillions to fade. Time itself moves gently out there. And in that gentleness, your mind begins to loosen its grip. The things that felt heavy start to feel lighter, not because they magically disappear, but because their scale becomes clearer. You are surrounded by a universe that is calm, ancient, and endlessly patient. And that patience settles into you too, like a soft weight across your shoulders, reminding you that you don't have to solve everything tonight. Your worries drift outward, just a little. They find space between the stars. They become manageable, breathable, held by something older and kinder than anything you face today. And in that vastness, a quiet gratitude begins to rise. Because even your heaviest thoughts are small enough to set down for a while. There's a special kind of peace that arrives when you pause long enough to notice how gently the universe truly behaves. Stars glow for billions of years with patient light. Galaxies drift in slow spirals that take entire cosmic eras to complete a single turn. Black holes, despite their mysterious nature, remain some of the quietest structures in existence, influencing space with steady, calm gravity. When you look at the universe this way, gratitude begins to rise naturally, like a warm tide moving softly across the mind. You might find yourself appreciating how everything follows simple, peaceful laws. Gravity doesn't rush. Light doesn't hurry. Even time itself moves with a soft, measured rhythm. In that rhythm, there is comfort. The universe doesn't demand anything from you. It simply offers its quiet presence, like a companion sitting beside you in stillness. This gratitude isn't loud or ecstatic. It's gentle, the kind that settles behind the ribs, loosening tension, reminding you that you're part of something vast and patient. You are surrounded by cosmic calm, and that calm is older than galaxies. Think about how remarkable it is that the universe doesn't constantly churn with chaos. Most of space is silent. Most of time is slow. Most of the cosmos exists in peaceful equilibrium. Black holes, stars, planets, dust, all drifting in long, unbroken motion. And here you are, breathing in that same universe, held together by the same forces, made of the same atoms forged in ancient stars. Gratitude becomes a natural response, a quiet thank you to existence itself. In this soft awareness, the mind relaxes, the heart steadies, the body loosens. Gratitude turns into comfort, comfort turns into peace, and peace prepares you gently for rest. There comes a moment in the night when everything softens. Thoughts grow slower, the body grows heavier, and the mind begins to loosen its grip on the day. It's a quiet threshold, delicate and gentle, like standing at the edge of a calm shoreline. This space between waking and sleep is its own kind of horizon. Not sharp, not sudden, but smooth and inviting. And as you rest here, you begin to sense how naturally your awareness drifts toward silence, the way light drifts toward the calm boundary around a black hole. Nothing pulls you harshly, nothing urges you forward. You simply glide closer to stillness with each slow breath, moving at the same tranquil pace the universe prefers. This horizon of sleep doesn't demand anything from you. It asks nothing to be solved, nothing to be remembered. It just waits quietly, like a soft rim of gravity where the mind begins to release its shape. And as you hover here, you may notice how your thoughts stretch out, becoming thin and warm, like fading starlight. Each idea loses its edges. Each memory grows distant and harmless. The mind begins to drift in wide arcs, drifting away from the center of wakefulness. It all feels gentle, as if your thoughts are dissolving into a slow cosmic tide. Crossing this inner horizon is a natural motion. There is no barrier, no noise, no effort, just a subtle tilt toward softness, like leaning into a warm breeze. This is the moment where awareness becomes light, where tension melts, where the mind begins to dim like the last glow of twilight. And with one more slow breath, you drift just a little closer toward the deeper calm, waiting beyond this quiet threshold. As you rest here, the universe begins to feel softer, darker, and more comforting. Like a warm night that slowly gathers around you, imagine yourself drifting inward the way matter drifts toward the center of a supermassive black hole. Not pulled violently, not rushed, but guided by a slow, steady cosmic invitation. In a black hole of enormous size, the journey inward is gentle. Space curves smoothly. Time stretches calmly. Nothing tugs or twits. Everything simply flows downward, inward, deeper. Like a leaf settling onto still water, your thoughts can move this same way now. Slow, weightless, unhurried. Imagine each thought as a tiny particle floating on a soft gravitational current. There is no need to hold on to any of them. They drift naturally. They fade on their own. You don't have to force anything. Just let the mind follow the quiet, inward slope of relaxation. As you drift deeper, your breath becomes slower, more grounded. Each inhale feels like rising slightly through warm air. Each exhale feels like sinking back into a quiet gravitational pool. The body becomes heavier, softer, more at ease. The muscles loosen, one by one, like stars dimming gently across the night. Inside this calm descent, time begins to blur. Minutes stretch. Awareness softens. The edges of the world dissolve into a peaceful haze. This is the universe preparing a place for you, a quiet space where nothing is expected, nothing is required, nothing moves faster than your own comfort. Let yourself drift deeper still, toward the soft center of rest, toward the quiet curve of sleep, toward the warm darkness that holds you gently. You are drifting inward now, slowly, peacefully, exactly the way the universe intended. You are lying here now in the stillness of your room, and the universe feels very far away. Yet in truth, it has never been closer. Everything that rests within you, every atom, every quiet spark of thought, was born from ancient stars. You are shaped by the same forces that guide galaxies, the same gentle laws that cradle black holes in their timeless silence. And for a moment, as your breath softens, that connection becomes unmistakably clear. The universe has always carried a quiet patience. Stars take millions of years to glow, galaxies drift for billions, and black holes breathe in rhythm so slow they feel eternal. And you, without even trying, are part of that same calm rhythm. Your heartbeat settles like a small echo of cosmic timing. Your thoughts dim like starlight, softening at the horizon. Your body becomes still, as if the universe is holding you in its gravity. Whenever life feels loud or rushed or heavy, remember this gentle truth. The cosmos itself is never in a hurry. It moves with steady grace, with soft precision, with an ancient quiet that you carry inside you too. You belong to that vastness. You belong to that calm. As you drift deeper now, imagine yourself floating quietly among the stars, weightless, unhurried, surrounded by soft light and endless space. No pressure, no noise, just the same serenity that has guided the universe since the first moment light ever bloomed. And as you exhale, feel the world loosen around you as if the cosmos is easing every boundary, every thought, every lingering tension. You are part of something beautiful, something timeless, something deeply peaceful. The journey gently fades, and the rest is quiet. If your mind feels lighter now, if your breath has slowed, and the world feels just a little softer, then let this calm stay with you. The universe moves gently, and so can you. Thank you for drifting through the cosmos with the gentle physicist. You're welcome to return here anytime, whenever you need quiet, whenever you need rest, whenever you want to fall asleep among the stars. For now, let the night hold you. Let your thoughts grow distant, and let sleep take you the rest of the way, softly, slowly, peacefully. Good night.